Welcome to Performance Optimization and Scalability. In this course, you'll explore essential strategies to build high-performing, scalable applications, from caching and query optimization to scalable architecture design and leveraging Microsoft Copilot. You'll gain the skills to enhance efficiency and meet the demands of modern development. We will begin by exploring caching strategies and learning how to enhance application performance using in-memory and distributed caching. You'll also examine cache expiration techniques and best practices to maintain efficient and scalable systems. Then, we will examine database query optimization, focusing on indexing strategies, performance analysis techniques, and approaches for refining complex queries. You'll also discover best practices for ensuring consistent, high-performance databases. After that, we will identify the principles of scalable application design, exploring architectural patterns, load balancing, and asynchronous processing. You'll learn how to build adaptable and efficient systems that support growing demands. Finally, you'll leverage Microsoft Copilot to optimize application code and database performance. You'll apply its features to identify bottlenecks, refine code, and implement comprehensive performance enhancements across your applications. By the end of this course, you'll have the expertise to design and optimize high-performing, scalable applications, from mastering caching and query optimization to building efficient architectures and leveraging Microsoft Copilot. You'll be well prepared to tackle the challenges of modern application development. Let's begin.
My name is Paul Party, and I'm your instructor for this course. I've been programming computers since I was in my teens. I love programming because it's like solving puzzles while designing and creating something amazing. My graduate degree is in philosophy, where I learned how to become a better thinker. When I program computers, I can apply many of the logic skills I learned in philosophy. Computer programming not only enables you to build cool software, but I believe it can help make you a better thinker. I started my software development career at Microsoft when the internet was just getting started, and I participated in the internet revolution firsthand. I managed software engineering teams that worked on desktop and web-based software. The internet gave software developers, particularly those working on user interface, incredible new opportunities. From mobile interfaces to websites, software developers are not only creating software that's functional, but also works of art. In my career, I managed and worked with teams at both Microsoft and PayPal that focused on customer-facing interfaces and learned how to make them great. I also spent part of my 20 years at Microsoft in training organizations where I learned how to communicate challenging ideas to new learners. I also was fortunate enough to have spent 15 years teaching non-majors philosophy at a university in Seattle. This reinforced my ability to teach learners difficult concepts using ideas they can relate to. There's nothing more satisfying than to witness a learner having an aha moment where they understand something new. I'm really excited about this program. I believe Microsoft has some of the most powerful and exciting software development tools available, and I can't wait for you to learn about them. I'm confident you'll have many of the aha moments as you gain new skills and reinforce existing ones. The learning experience in this course is designed to give you a comprehensive understanding of key concepts through various learning methods. You'll be guided through interactive, engaging materials that help you build practical and theoretical knowledge. Whether you're interested in front-end, back-end, or full-stack development, this program has the tools to support your growth every step of the way. Throughout the course, you'll be introduced to core concepts and key ideas in videos. These videos are designed to help you understand definitions, processes, and essential steps clearly and concisely. You'll get to absorb foundational knowledge, setting the stage for deeper exploration as you move forward. And when you need step-by-step guidance, screencasts will provide you with a detailed practical view. These screencasts will show you exactly what's on the screen and how to work through specific coding tasks. The course also includes readings that reinforce the key ideas presented in the videos. These readings are more than just supplementary material. They're job aids. You can print them out and use them as a reference while working on assignments or activities, helping to apply what you've learned in real-world situations more easily. Small activities are included to help you check your understanding of key ideas. These activities provide quick, interactive opportunities to practice what you've just learned. After completing each activity, you can compare your work with a fully explained example and answer key. This ensures that you always know if your answer is correct. Practical experience doing tasks you would in a job within this field is essential, and that's where guided labs come in. These labs take you through the implementation of different concepts step by step. As you work, you'll receive feedback and helpful hints, ensuring you can get the help you need when you need it. It's the perfect opportunity to practice in a controlled environment while learning by doing. After completing the guided labs, you'll move on to independent projects, or you try it. This is where you'll put your skills to the test, applying what you've learned in the labs. You'll work through real-world problems, cementing your understanding of the course material. The course will culminate in a practical project leveraging Microsoft Copilot that you can use as a portfolio artifact when you begin your job search in this field. As you progress through the program, the portfolio pieces will become stronger and better representations of the authentic experience you've gained. They'll showcase your understanding of code and the ability to implement different concepts from the developer program. This course guides you step by step from understanding concepts through videos and readings to apply them in activities, screencasts, and labs. Each part of the course builds on the last, helping you gain knowledge and authentic experience. By the end, you'll have completed real projects that not only showcase your skills, but can also be included in your portfolio as you start your career. Everything you do here will prepare you for success as a developer. Let's get started.
Throughout this course, you'll complete several guided labs. These labs are meant to give you an opportunity to practice your newly learned skills in an environment where you can get help and feedback as you complete coding challenges. This video will describe how to complete the guided labs in this course. We will explore a guided lab together so that you'll know what to expect when you come to one later in the course. First, let's check the content leading up to a guided lab. This structured content ensures that you have exactly the skills you need to complete the task. In this instance, there is a practical application video that describes in detail how this concept is used in real-world situations. Following this practical application video, you can review a reading that explains the concept in detail so you can go through this content at your own pace. Next, you'll find a video that works through the guided lab itself. This video won't give you all the answers to the guided lab, but it will provide an overview of the upcoming questions and challenges. Lastly, we come to the guided lab itself. The guided lab is a simulated code environment where you can experiment with code and receive hints and feedback in a realistic coding situation. To start, I'll click Start. In this lab, step 1 is an introduction to if-else statements, so I'll click Begin. Below the simulated code environment, I can find the specific instructions for this lab. Declare the variable age as type int. Place your cursor into line 2, type your answer, and select Enter to check your work. Alright, I think I know this one. I'm going to type in INT and hit Enter. Great, I got that correct, and I got a bit of feedback about my correct answer. To move on, I click Continue. And these instructions say, prompt the user to enter their age, place your cursor into line 4, type your answer, and select Enter to check your work. This one is a little trickier. Let me try type your age. Got it. This feedback for my wrong answer points me in the right direction. Let's try that again. I'm going to erase what I had here and then enter your age. Perfect. I'll click Continue. Let's try one more. Convert the input to an integer using int.parse and store it in the age variable. Place your cursor into line 6, type your answer, and select Enter to check your work. I'm not totally sure here, so I'm going to click on Hint and get some help. And the hint says use console.readline and then an open and close parentheses, display a message asking their user for their age. Great, that helps. I'm going to click continue and type in console.readline. And I've got it. That's how you work through a guided lab. Some questions will require more complex code to complete, so make sure you're using the hint function when you need it and reviewing the feedback provided for your right and wrong answers. Have fun completing these coding challenges that put your new skills to work.
In today's rapidly evolving tech landscape, artificial intelligence plays a key role in making development more efficient and intelligent. That's where Microsoft Copilot comes in. Microsoft Copilot is a powerful AI-driven tool that can assist developers in writing, optimizing, and debugging code. In this course, you'll leverage Copilot as a thought partner and a code-generating assistant, helping you solve problems, generate code snippets, and enhance your projects. The goal is to provide you with hands-on experience using a tool that real-world developers use to improve their workflow. In the last module of this course, you'll engage in videos, screencasts, guided labs, and independent projects that integrate Copilot. These labs will take you through how to use specific prompts to generate code, optimize solutions, and solve problems. You'll be shown step-by-step how to leverage Copilot's capabilities to strategically approach the final project. During the guided labs, you'll get hands-on experience working with Copilot. These labs are structured to show you how to craft effective prompts and work with Copilot's code generation features. You'll use it to assist in writing code, refining your solutions, and debugging. This practice will prepare you for the independent work you'll do in the final project. After the videos, screencasts, or guided labs, you'll move on to independent activities where you'll take control. Here you'll use Copilot to assist with various aspects of the project. You'll be making strategic decisions, but Copilot will support you by generating code, suggesting optimizations, and helping you troubleshoot. This prepares you to work more independently while still having the power of AI to assist. The final project will combine everything you've learned in the course, and you'll have Copilot as a key tool in your development toolkit. You'll use Copilot to help you generate and refine code as you combine the concepts from earlier lessons. The project is a portfolio-ready artifact showcasing your coding skills and your ability to leverage AI in modern development workflows. To succeed in the final module, actively engage with the guided labs and practice using Microsoft Copilot effectively. The videos and prompts will take you through Copilot and equip you to apply it strategically and independently. By the end of the course, you'll be fully prepared to complete the final project and demonstrate your skills using traditional coding and AI-assisted workflows. Welcome to the course. In this video, we will discuss how you can make the most of each part of the course to set yourself up for success. Whether you watch the videos, complete activities, or work through hands-on labs, each element has been designed to help you master the skills you need to become a confident and capable developer. The first step in every lesson is the videos. You'll be introduced to new concepts, definitions, and key ideas. Watch these carefully and take notes on the important points. The videos provide the foundational knowledge you'll need to build on, so don't skip them. They'll give you the context to understand everything that comes next. After each video, complete the readings. These readings reinforce the key ideas you've just learned and can serve as job aids. I recommend printing out the readings or saving them for quick reference. They'll be extremely helpful when completing activities, working on projects, or just needing a refresher. They're not just supplementary. They help you apply what you've learned to real-world tasks. Throughout the course, you'll find small but impactful activities. These quick exercises allow you to check your understanding of key ideas. Don't rush through them. Take the time to work through these activities thoughtfully. After each, compare answers with the answer key to check how well you understand the material. This is your chance to practice without pressure. At the end of each lesson, you'll encounter practice quizzes. These quizzes are a great way to ensure you fully grasp the concepts from the videos and the readings. Use these as a checkpoint to assess how well you retain the information. If you find yourself struggling, review the videos and readings again. The goal is to build confidence and solidify your understanding before moving forward. When you need to see the material in action, screencasts guide you. These videos show you exactly how to work through certain tasks step by step. If you ever feel stuck or unsure about applying a concept, watch the screencasts and follow along. This hands-on guidance is invaluable for understanding how the code works in real time and applying what you've learned. At the end of each module, there will be graded quizzes. These are an important part of your success as they allow you to demonstrate mastery of the material. These quizzes build on the practice quizzes, and they're a great way to ensure you're ready to move on to more advanced concepts. Treat these quizzes as milestones. Passing them means you're fully prepared for the next challenge. The guided labs are where you'll take the concepts from the lessons and apply them in a controlled, hands-on environment. These labs will take you step by step through tasks, including helpful feedback and hints. The more effort you put into the labs, the more you'll get out of them. It's all about learning by doing, so take your time and ensure you understand each step before moving on. After you've completed the guided labs, it's time to test your skills with independent projects or U-try-its. This is where you'll apply everything you've learned without step-by-step instructions. These projects are a great way to gauge how far you've come and to put your knowledge to the test. Don't worry if you feel a challenge, that's part of the learning process. By completing these projects, you'll reinforce your skills and build confidence. Finally, at the end of the course, you'll complete a culminating hands-on project that you can use as a portfolio artifact. This project will showcase the skills you've gained throughout the course and give you something tangible to present to potential employers. As you progress through the program, these portfolio pieces will become stronger representations of your hands-on experience and understanding of key concepts. Success in this course comes down to using all the tools available. Watch the videos carefully, engage with the readings, complete the activities and quizzes thoughtfully, and take full advantage of the screencasts, labs, and projects. Each element of this course is designed to help you master the material step by step. By the end, you'll have a solid understanding of the concepts and real projects to prove your skills. Remember to persist, take your time, and you'll be ready for a successful career in development. To bring together all that you've learned in this course, you'll complete a project focused on performance optimization and scalability with Microsoft Copilot. By the end of this project, you will have optimized and debugged a performance-driven order management system for Warehouse X, a logistics company that relies on efficient database operations and application logic. Whether you're tackling this challenge to impress potential employers, refine your problem-solving abilities, or deepen your expertise in performance optimization, this project is your chance to shine. And don't worry, you won't be doing it alone. Microsoft Copilot will be your assistant, helping you analyze, refine, and enhance your code at every step. In this video, we'll introduce your final project where you'll systematically optimize Warehouse X's order management system. By completing this project, you'll have improved SQL query performance, streamlined application logic, and debugged critical errors, ensuring a smooth and efficient system. Using Microsoft Copilot, you'll identify inefficiencies, apply best practices, and measure performance improvements along the way. Whether you're new to performance optimization or have some experience, this project is structured to guide you through key techniques in database tuning, application enhancements, and debugging. Let's take a closer look at what you'll be working on. Your task is to enhance the performance and stability of Warehouse X's order management system, focusing on 4 key areas. To begin, you'll develop a strategic optimization plan. You'll outline potential performance issues affecting database queries, application logic, and error handling, ensuring a structured approach before making changes. Then, you'll optimize SQL queries. You'll improve database efficiency by refining queries, implementing indexing, and optimizing data retrieval. Next, you'll optimize application code. You'll enhance back-end logic by eliminating redundant database calls, optimizing loops, and refining I/O operations. Finally, you'll approach debugging and error handling. You'll identify and fix issues such as unhandled exceptions, null reference errors, and stability concerns. Throughout this project, Copilot will provide real-time suggestions to help you. It will generate structured optimization plans tailored to database and application performance, detect and resolve inefficiencies in SQL queries and backend logic, and debug and enhance code stability using AI-driven insights. The project is divided into 4 structured activities. In Activity 1, you'll analyze Warehouse X's performance issues and outline a strategic plan for SQL improvements, application enhancements, and debugging strategies. Then in Activity 2, you'll apply indexing and restructuring techniques to improve database query speed and efficiency. Next, in Activity 3, you'll refine inefficient backend logic, eliminate redundant queries, and enhance processing speed. Finally, in Activity 4, you'll debug and test the system, addressing stability issues and ensuring smooth order processing. Each activity builds on the previous one to ensure a structured learning experience, and Copilot will be there to provide suggestions, guide optimizations, and streamline your workflow. Following the step-by-step instructions, you'll complete this project to optimize and stabilize an order management system that you can confidently showcase in your portfolio. This will highlight your back-end development expertise and demonstrate your ability to use AI-powered tools like Microsoft Copilot to solve real-world performance challenges. This end-of-the-course project is your opportunity to take your skills to the next level and create something impactful. It may be challenging, but it will also be a rewarding experience, leaving you with expertise that can help you as you gain more back-end development knowledge.
Welcome to Caching Strategies with .NET Core. In this module, you'll learn how caching boosts application performance and scalability. By implementing in-memory and distributed caching and managing expiration policy, you'll gain the skills to optimize .NET Core applications for efficiency and reliability. We will begin by introducing the foundational concepts of caching, uncovering its importance in enhancing application performance and reducing redundant operations. Next, we will examine caching strategies, exploring the differences between in-memory and distributed caching while identifying the scenarios where each is most effective. Then, we will focus on implementing in-memory caching, walking through practical steps to store and retrieve data efficiently within an application. After that, we will explore distributed caching systems, ensuring seamless performance and scalability for applications operating in multiple server environments. Finally, we'll address cache expiration policies, learning how to balance data freshness and performance by applying strategies to manage cache lifecycles effectively. By the end of this module, you'll have the tools and strategies to enhance application performance and scalability through effective caching techniques. Let's get started. Imagine opening a website and everything appears instantly. Images, menus, and content without delay. This is the power of caching, a simple strategy that creates speed and efficiency in applications. In this video, we'll explain caching and its uses. To understand how applications use caching to achieve a high level of speed and efficiency, let's begin by defining it. Caching is the temporary storage of frequently accessed data to improve performance. Caching works by saving copies of data in a faster-to-access location like RAM or browser cache. For example, take a product image on a website. Instead of downloading the image every time a user visits, caching it in the browser keeps it ready to load instantly, making loading pages much faster. Now that we've defined caching, let's explore some of its benefits. Caching doesn't just store data, it significantly boosts the performance optimization of websites and applications. Performance optimization is the process of improving the speed, efficiency, and responsiveness of an application, system, or process to ensure it meets desired performance goals. It involves identifying bottlenecks, reducing resource usage and enhancing the overall user experience. By storing data in a faster-to-access location, like the browser, caching reduces retrieval times, allowing data to be accessed much faster than repeatedly fetching it from its original source. For example, cached CSS files stored in the browser ensure web pages display immediately when visited, creating a better browsing experience. Caching also helps with faster data retrieval rates. For instance, a navigation menu stored in the browser cache doesn't need to reload whenever a user selects options in the app. Instead, it's accessed directly from the user's device, creating a faster overall experience. Next, caching can enhance scalability by reducing redundant data processing and lightening the server's load, especially during busy periods. For example, during a big online sale, caching product lists prevents the server from repeatedly recreating the same data. This allows it to handle new requests more efficiently, ensuring consistent performance and a reliable user experience even during high traffic spikes. Finally, caching can improve the performance of frequently accessed data, like API endpoints, product pages, and session information. By reducing repeated database queries and avoiding the need to regenerate the same data, caching ensures faster load times, smoother user experiences, and consistent performance, even during high traffic periods. For example, caching product categories enables instant loading, cached product pages maintain smooth shopping experiences during peak traffic, and session caching keeps shopping carts active for returning users. In this video, you learned about caching and its uses. Caching is a foundational step in creating faster, smarter applications that can efficiently handle the demands of real-world users by minimizing delays and optimizing resource usage. Every second matters to users while using web applications, and caching is a key component. Caching is a powerful optimization technique that transforms slow, resource-intensive systems into fast and responsive experiences, ensuring users stay engaged and satisfied. In this video, we'll describe how caching improves the performance of web applications. Let's begin by exploring how caching helps with performance optimization. Caching significantly reduces response time by storing data in a faster-to-access location, eliminating the need to compute or fetch it repeatedly. For example, consider an online store. When users visit and then revisit a product page, images and details will load instantly because they have been cached. This minimizes delays and ensures a smooth browsing experience, even for repeat visits. Caching also reduces reliance on database queries, improving speed and optimizing application performance. By storing results in a cache, the application can serve data without constantly overburdening the database with queries. This allows for faster responses and ensures the system can handle higher traffic during peak times. For example, imagine a travel booking site where users frequently search for popular destinations like New York City or Paris. With caching, search results for these destinations are stored temporarily, allowing the system to deliver instant results without repeatedly querying the database, significantly reducing load times and improving user experience. An additional way caching improves performance optimization is by minimizing system workload during high traffic events and optimizing server resources. For example, news sites often cache popular articles, headlines, or summaries. During peak moments like breaking news, the server can quickly serve cached data instead of repeatedly generating the same response. This ensures server resources are available for unique or new requests, keeping the site responsive and stable even under those high loads. Finally, latency management helps to optimize performance by reducing system response delays. Latency management refers to strategies and techniques for minimizing the time between a user's request and the system's response. Caching plays a significant role in latency management by storing frequently accessed data closer to the user. For example, a streaming platform might cache video metadata. This allows users to start watching their favorite shows with minimal delay, even during those busy periods. In this video, you learned about how caching improves the performance of web applications by reducing response times, database queries, and server loads while managing latency, caching ensures your application stays fast, scalable, and ready to meet your users' demands. Ever feel like your computer is trying to find that one file forever? In-memory caching is a key tool for ensuring applications deliver information faster than ever and offer users a seamless user experience. In this video, we'll describe how in-memory caching works and its use cases. Let's begin by defining RAM, or Random Access Memory, which is critical for in-memory caching. RAM is a temporary, high-speed memory used by a computer to store data actively being processed or used. Random access memory allows the system to quickly access and manipulate data while running programs. Now that we understand what RAM is, let's define in-memory caching. In-memory caching is a caching technique that temporarily stores data in RAM. In-memory caching significantly reduces response times by keeping frequently accessed data close to the system in RAM rather than on hard drives or databases. It is very useful in scenarios where data is frequently accessed, such as web applications, databases, and content delivery systems, to speed up response times and reduce load on slower storage systems. Next, let's explore the key features that make in-memory caching an effective tool. One of the most useful features of in-memory caching is its fast access. By storing data in RAM, applications can access it almost instantly. This makes it ideal for scenarios like displaying news headlines on a homepage, where users expect updates to load quickly. In-memory cache data is also stored temporarily and cleared when the system restarts. This feature makes in-memory caching perfect for short-term use cases, like holding shopping cart items using a browser's session. Another feature of in-memory caching is that it typically operates on a single server, which limits its scalability. As a result, it's most suitable for smaller setups, like quickly displaying scores on a game leaderboard accessed by users connected to the same server. A final feature of in-memory caching is that it is supported by various tools and frameworks that simplify its implementation. For example, in .NET, the tool iMemory Cache library offers developers an easy way to manage cache data. These tools enable developers to integrate caching strategies in real-world applications, improve performance and responsiveness. With these features in mind, let's explore some specific scenarios where in-memory caching is useful. In-memory caching excels in applications that frequently access or display the same data. For example, product lists in an e-commerce store or popular posts on a social media feed can be cached to ensure users can access content quickly without repeated database queries. Another valuable use case is caching the results of computationally expensive processes. For example, a weather app can store today's forecast in memory, eliminating the need to recalculate it every time a user checks the app. This approach speeds up response times and reduces the app's computational load, reducing costs. It's important to remember that cache data is cleared when the system restarts. This makes in-memory caching unsuitable for storing critical information like online banking records, which must remain available even after a reboot. For such data, a persistent storage solution like a database is essential. In this video, you learned how in-memory caching works and its use cases. Speed and efficiency are crucial for delivering exceptional application experiences, and in-memory caching is pivotal in achieving both. Web applications will encounter significant challenges during peak traffic, often resulting in slow page loads and frustrated customers. To prevent this, backend developers will leverage a highly scalable solution like distributed caching to help ensure a seamless user experience. In this video, we'll explain the purpose and benefits of distributed caching. Let's start by understanding what distributed caching is and how it works to improve performance. Distributed caching stores frequently accessed data across multiple servers, unlike traditional caching, which is limited to a single server. Distributed caching spreads the cache workload across a cluster of servers. This approach reduces data access times, prevents bottlenecks, and ensures the system can handle high traffic by distributing the load efficiently, allowing each server to manage a smaller portion of data. Now that we've defined distributed caching, let's explore some of its key elements. Distributed caching ensures scalability by reducing the load on the database, distributing data requests across multiple cache nodes, and working alongside load balancers to evenly distribute incoming traffic across servers. Load balancers are tools that distribute incoming network traffic across multiple servers in a cluster. This ensures no single server is overloaded, improving the overall availability and reliability of the application. Meanwhile, distributed caching reduces database loads by serving frequently accessed data from cache nodes across the cluster. For example, during a flash sale with thousands of users shopping simultaneously on an online store, distributed caching offloads the database by quickly providing cached data, while load balancers ensure traffic is evenly spread across the server. Together, these mechanisms enable applications to scale efficiently and remain responsive under heavy demand. While scalability is key, consistency across servers ensures that data updates are synchronized. For instance, when users update their profile picture, distributed caching ensures every server instantly reflects that change. Tools like Redis and Memcached are commonly used to maintain its consistency. With distributed caching, users always access accurate, up-to-date information, no matter where they connect from. Finally, let's explore use cases where distributed caching is most effective. Distributed caching is essential for modern architectures like microservices and cloud-based systems. In microservices, applications are divided into smaller, independent components, and caching helps these components share data quickly without overloading a single database. Similarly, in cloud-based systems, which are hosted across multiple servers, distributed caching ensures fast and reliable access to data. For instance, caching user credentials allows a login service to process authentication faster, creating a more efficient user experience. In this video, you learned about the purpose and benefits of distributed caching. Distributed caching transforms how applications handle growth and user demands, ensuring speed and consistency at scale.
In this screencast, we're going to demonstrate how to configure in-memory caching using iMemory Cache. I have a simple console application here that we're going to use to illustrate how to use and enable iMemory Cache. I'm using the Microsoft.extensions.caching.memory class, that library, and you can see I'm referencing it here at the top using Microsoft.extensions.caching.memory, which is just an in-memory cache that we'll use. I had to install that as a package before I could run the application. We have the main method here that is run when the application runs. And you can see our first line is to create an iMemory cache type with a variable called cache. And it's just a new memory cache with some options. We're setting a size limit of 1024 on this cache. That's obviously variable, but that gives us our cache object that we can now use to store data. We're going to also set up another variable called key, and we're setting that value to user profiles. In the rest of the body of the main method, I have a for loop to illustrate how the cache works. It iterates 3 times, and it's going to attempt to pull data from the cache. If the data doesn't exist, it's going to add the data to the cache, and if it does exist, it'll pull the data from the cache. So the first if statement is essentially saying if we try to get the value out of the cache and it doesn't exist, then it's going to tell us that there's a cache miss. In other words, it couldn't find the data that we're looking for, so we're going to fetch our user profile. We're filling a variable called user with the result of the method fetch user profiles, and that simply just returns a string list with Alice, Bob, and Charlie as data options. And this is again a simulated query result. Obviously in the real world this would be a lot more complex, but this just illustrates how the cache works. So it fills the user variable with the result of that method call. We essentially place those items in memory cache. So we have our key, which we've set above as user profiles. We have the users list, and then we set up new memory cache options, and then we place our data into that cache. And so now it will live there for up to 30 seconds, and we can ping it for 30 seconds. We can try to get the data from it. It then tells us that our user profiles were added to the cache, and if it does find data from the cache, then it will retrieve that data and use that data and tell us that the retrieved data was from the cache. And then it will actually write out the data that it retrieved. The last thing it will do after it runs through this for loop 3 times, attempting to hit the cache, is that it will clear it. If the cache doesn't have a value, then it will essentially clear out the cache and tell us that it cleared out. Otherwise, it'll tell us that the cache still exists. I put a little 3-second delay in here so that we can simulate going through that item so it won't appear on the screen too rapidly. The final option is actually removing the data from the cache using cache.remove, and we're passing in that key to let it know what data we want it to remove from the cache. So I'm going to go ahead and run this. We should see all these messages telling us what's happening. It said the user profile were added to the cache, and it tells us what the cache data is, Alice, Bob, and Charlie. And then it just informs us that the cache now exists. And then next time it goes through the loop, you can see it said cache hit, retrieve data from the cache, and it tells us what that cache data is, Alice, Bob, and Charlie. It didn't have to re-add the data or go to that method to get the data. It just used it from the in-memory cache. You can imagine in a real-world scenario going out to an API or retrieving data from a database. Instead of having to do that, it just uses the cached data for a period of time. Again, ours is 30 seconds. You can set that to any length that you'd like, and it will use cache data. Caches are optimal for when you don't update data very often. These can be a lot faster than having to make API calls or to retrieve data from a database. If you can use a cache and that data just remains static for a long period of time, it can greatly improve the performance of your app. The third time through, it hit the cache again and retrieved data from the cache, and it let us know that the cache still exists. And then finally, that last line, after it iterates through 3 times, it runs cache.removed and tells us that it's removing the cache data. Now that data is no longer in the cache, so if we were to try to get that data again from the cache, it would be missing, so it would go back to fetch user profiles to retrieve that data from the cache. So this is just a very simple application to show how you can set up an in-memory cache and then use that to store and retrieve data.
Building on foundational concepts, this segment delves into managing cache entries with iMemory Cache, a critical step for enhancing performance and ensuring reliable, scalable applications. Through this, you'll explore strategies to handle cache limitations, address misses, and maintain efficient operations. In this video, we'll explain how to manage cache entries with iMemory Cache. To begin, let's explore how managing cache enhances performance with iMemory Cache. iMemory Cache is a caching interface in ASP.NET Core that stores data temporarily in memory for quick access. It enables developers to cache frequently accessed or computationally expensive data in the server's memory, significantly reducing response times and system load. Now that we understand what iMemory Cache is, let's explore how it is used to manage cache operations. With iMemory Cache, you can define cache size and limits to control how much data your application caches. This ensures your app remains efficient even under heavy use. Managing the amount of data stored in the cache is essential to prevent memory overuse. In code, using iMemory Cache, the cache is created using a memory cache options object. For this example, we have set the size limit using sizeLimit to 1024, representing the cache's maximum capacity. The size is measured in arbitrary units, representing the number of items or any custom metric you allocate. This configuration ensures the cache doesn't exceed its capacity, helping maintain stable memory usage. However, defining size limits is only part of the equation. What happens when the requested data isn't already in the cache? That's when you must figure out how to handle cache misses. A cache miss happens when the requested data isn't found in the cache. When this occurs, the application retrieves the data from the database and adds it to the cache for future use. Before fetching data, the app checks if it's already available in the cache. This is done using the try-get-value method. If, for example, the product in product list isn't found, try_get_value returns false, and the product's variable remains uninitialized. This triggers the subsequent code to fetch data from the database. When the cache doesn't contain the data, the app retrieves it asynchronously using dbcontext.getProductsAsync. This ensures the app can continue handling other tasks without being blocked, making the retrieval process efficient. Once the data is fetched, the next step is to store it in the cache with appropriate settings. By specifying its size and expiration, we ensure the cache remains optimized and ready for future requests. In iMemory cache, the absolute expiration relative to now setting defines how long the data will stay in the cache. Meanwhile, the size property ensures each entry contributes to the overall size limit, maintaining control over memory usage. Together, these settings help maintain control over memory usage while keeping the cache efficient and well organized. Clearing stale or irrelevant cache entries ensures users always interact with accurate data if the cache has become outdated. This is especially true in dynamic applications where information changes frequently. Using the remove method, you can delete the cache entry identified by the key product list. This ensures that the next time the app requests this data, it fetches the latest version from the database. In this video, you learned how to manage cache entries with iMemory Cache. With iMemory Cache, you can transform your app's performance by effectively managing memory, minimizing delays from cache misses, and keeping data fresh.
In this lab, we'll be implementing in-memory caching using iMemory Cache in a .NET application. In step one, we're going to configure in-memory caching. And I have a simple web API .NET application here. And we're going to do everything in program.cs. So the first thing we want to do is make sure we have a reference to the library that we need, the Microsoft Extensions Caching Memory Library. So that will allow us to use the in-memory cache. And this is just built into the .NET framework, so we don't have to use a third-party library for this. Then we're going to add the memory cache to our builder. So we're going to do builder.services.add memory cache so that we have a reference to the memory cache. And then we can use that throughout the program. Now in step two, we're going to store data in the cache. So I'm going to go down to this block of code. We have all of the rest of our setup for our application up top. And now we're going to go into using the memory cache here in this code. So the first thing we'll do is set up a reference to the iMemory cache using the cache variable. And we're going to set up some options here. In a second, we will include those in our call to the memory cache. Then we set up a string called key with the name is just employee list. This is a key for our cache, so we know which key to reference when we want to retrieve data from the cache and write memory to the cache. And then we set up a list of string elements called employees, and we're going to add 3 names to that, Alice, Bob, and Charlie. So we've got our variable, we have our data for the cache, and we've got our key for the cache. Then the next command is to set the cache. We're going to send the data to the cache using the key that we just set up. So that's what that cache.set does. That sets data or pushes data to the cache. And notice that we're going to add some options here. We're going to set the time span for the cache to 60 seconds. And that's all that option does. In step 3, we're going to set up code to retrieve data from the cache. And here we're using a get route, which is just at the root of the server. And the first thing we want to do is try to grab the values from the cache. So we're going to make the call cache.tryGetValue, which is the method we'll use. And we're going to pass in the key that we created earlier. And we're going to pull that into a variable called cached employees. So this is how we're trying to use that method to get the data from the cache. Notice that we're using the exclamation point, which tells us if this fails. So if not something, right? Put it another way, if we can't get the data from the cache, we'll write out to the console that the cache was missed, and then we'll use the fetch employees method instead, which is getting data from the application itself rather from the cache. So we'll fetch employees, and we're just going to return those 3 names again. In a real world instance, we would go out to a database or make an API call and get the data from that.
But here we're going to try to get it from the cache first, which saves the time of reading from a database or going out to an API. If we do get the data from the cache, we don't need to populate anything. We don't need to fill cached employees because we do that in our try get value call. Just write out to the console that we hit the cache, and then we return the results to the console. We'll write out those 3 names. And that's what's involved in using an in-memory cache for this lab. In this screencast, we're going to demonstrate how to install and configure Redis for distributed caching. I have a simple web application set up here. In this application, I've modified program.cs to use Redis in the background. I'm added the package you can see here in the terminal window. I've added the package microsoft.extensions.caching.stackexchange Redis. That library is what we'll be able to use the Redis cache that will be running in our Linux subsystem. In the program.cs file, I've added 2 configuration options. Both are added to the builder services object, and I'm using the add stack exchange Redis cache method to add these options. The first one is Redis configuration, and the second is Redis instance name, and we'll use those when we operate our cache. Now I'm going to go over to another file in a controllers folder called event controller. In this controller, I essentially have routes that we're going to call. This is using dependency injection to store items in the Redis cache. And so even though we don't see Redis in the name here anywhere, iDistributed cache is using whatever cache we've set up in our program.cs file, and that's a Redis cache. So I've got a few controllers here. I have API/events, which is the main route that we'll be using. And we have a store event, which is an event is what we would put into Redis. The first method that we have here is store event. And so we're going to get the event ID, and we're going to serialize JSON data, which is the data that will pass to the method. I want to call out that this is also a post method. So we're going to actually send data to this method. We'll serialize the JSON, and then we'll create an event out of that. So you can see we have options equals new distributed cache entry options. So we set a expiration for the cache for 10 minutes. So that's if we request information from the cache. If that item is in there, it will use the cached version. If it expired, it will refresh the cache with the new item. And then of course, if the item doesn't exist, it will add it to the cache. So this is the first route that we have, the store route. And then we have a retrieve route, which we pass in the ID for that route. And this is where we pull items from the cache. So you can see we get a byte object cache data, and we reference the cache object and then use the get async method with a specific key that we pass in to retrieve the data from the cache. If the cache data isn't null, then we get a JSON string. We deserialize that string, and then we bring that back out into our application so that we can either view it or do something with it. We also have the option to delete items from the cache. Again, we're passing in the ID here, and this is the delete method, and we use the remove event method inside the HTTP delete method to remove items from the cache using that ID and key again. The remove the cache _cache.remove async is the actual cache method that we're using from the cache library to remove the item from the cache. We have a final method, a get method here, monitor cache, where we can just see what's going on inside the cache. We pass in the ID again for the specific event that we added to the cache, and then we can just see if it's in there and what the status is. Finally, we have an event model class, which we're using to store the data from the cache that we're passing in. And we have an int ID field, a string name, a string location, and a date time date. And we'll use those to store the information that we're passing to it. And that's really all that there is to it for this application. We have the 4 methods that we'll use. We'll have the cache running in the background. So the first thing I'm going to do is start this application. So we can now make the method calls to that. But we also need to start Redis. So I'm going to go to my terminal in Windows, and I'm going to run Redis server here. So when I run this, will create that Redis server in the background. you'll see that this is running on port 6379. And in our application, we also have set that information for us to look at 8379 somewhere in here. It's in our app settings.json. So we have our Redis information. The configuration is running at localhost 6379, and we're just calling our instance name Redis event cache. So now we're able to make calls to our API and store the data in the Redis cache. I'm going to use Postman to do this. The first method I'm going to call is the post method, which we saw in our application, and I'm going to send this body data. So you'll see here's the 4 items that we also created a class for: ID, name, location, and date. And we're going to send in ID1, name, tech conference, location, New York, and the date is 3/15/2025. So we're going to send all this data in the body of our request as JSON, because that's what we're serializing and deserializing in our app. And then this is our route that we had seen in the application itself. So I'm going to go ahead and send. And it tells me that there's event 1 stored in Redis. So that means that we have an ID now for our first event, and it's event 1. And then we can use that event 1, or a 1 is the ID, to retrieve data and to interact with it. So let's go make another call from Postman. And this is retrieving information for the event 1. So you can see at the end of the get route, we're passing in /1, which is the ID that we saw in our application. So I'll go ahead and send that. And now we can see that we're getting our data back. And this is the retrieve side of that. We sent it earlier and we're getting the same data back. Now we can go ahead and use the delete method. So here we're calling remove. We're also passing in the ID /1. And when we hit send on that, it tells us that event 1 is removed from Redis. Now I'm going to go back to the get method and send again. It will tell me that the event is not found in the cache. So using that route, we were able to delete the event, and now it's not found in the cache. Using a get method, we can monitor the events that are in the cache. So I'll click send on that, and it tells me that there's a cache miss because we're passing in the ID /1, and that ID no longer exists. So if we go ahead and post again, we now have event 1 stored in Redis, and now when I go back to monitor, it will tell me that the cache was hit. That means when we monitor for that event, we did find an event with an ID of 1 in the cache, and so it tells me that it exists there. And so you can imagine some logic where you make a request to the Reddit server to see if it actually found something. If it did, then we can pull the value from the cache or whatever you want to do, or delete it or whatever. But that allows you to monitor what's happening. So that's how you can use a simple ASP.NET application to work with a Redis cache. This Redis cache is running on the Linux subsystem in Windows on this machine. You can also run, obviously, Redis natively on Linux if you're using a Linux machine.
Modern applications handle enormous amounts of data, and how you manage that data directly impacts performance and scalability. Redis, a distributed caching solution, is a powerful tool for effectively storing and retrieving frequently accessed data in .NET applications. In this video, we'll explain how to store and retrieve data from Redis in a distributed caching setup. Before we begin, let's define what Redis is and why it's widely used in modern applications. Redis is an open-source, in-memory data store that serves as a database cache and message broker. To work with Redis in .NET applications, you'll use the iDistributed Cache interface. Let's break down what it does and how it simplifies caching. iDistributed Cache is a .NET interface designed to interact with distributed caching solutions like Redis. It simplifies the process of caching frequently accessed data, such as user settings, helping to reduce database load and improve application response times. By leveraging Redis, applications can store and retrieve data more efficiently, ensuring faster responses to user requests. To understand how Redis integrates into this process, let's explore the key aspects of managing data with Redis. Caching frequently accessed data, like user settings, minimizes repetitive database queries, enabling applications to quickly deliver the information users need. This technique optimizes resource usage and enhances response times, especially in high-demand scenarios. The setAsync method in iDistributed Cache allows you to store key value pairs in Redis. before using Redis, ensure it's set up in your .NET application. For example, you can configure Redis in program.cs using the add stack exchange Redis cache method. Now, let's imagine you're building an e-commerce site where users select their favorite product category, such as electronics. To store this information in Redis, we use a key value pair. The key user:123:category identifies the specific user and their selection, while the value electronics represents the chosen category. This data is stored with UTF-8 encoding and configured to expire after 1 hour. After storing the data, the next step is retrieving it so your application can use the cached information to enhance the user experience. Retrieving cached data reduces the need to repeatedly query the database, saving time and resources. To access cached data, use idistributedcache.getAsync. This method attempts to retrieve the value associated with a given key from the cache. However, if the data isn't in the cache, it's important to have a fallback plan. This could involve querying the database to fetch the data and then storing it back into the cache for future use. When the user returns to the site, you want to fetch their selected category to personalize the homepage. We do this by first retrieving the user's category preference from Redis. If it's found, we decode its UTF-8, otherwise set it to default. Now that we've covered how to store and retrieve data, it's essential to ensure that cache data is synchronized and remains consistent across servers in distributed systems. Synchronization ensures that data in the cache is consistent, even when multiple servers are accessing it. In distributed systems, your application might run on multiple servers, and each server could need the same cache data. If the cache isn't synchronized, one server might retrieve outdated information while another has the updated version. One way to ensure consistency is by using a centralized Redis instance. For example, if a user's preferred category is updated to fashion, it's crucial to ensure that all servers can access this change. This is achieved by storing the updated value in a centralized Redis instance. When servers query Redis for user preferences, they retrieve the latest value stored in the cache, ensuring consistency across the application. By using a centralized caching system like Redis, you prevent inconsistencies caused by outdated or isolated caches, providing a seamless and consistent user experience by storing the value fashion in Redis with the key user:123:category, encoded as UTF-8 bytes. The final step is ensuring that your caching solution works efficiently. This involves monitoring the cache's performance and addressing any issues as they arise. Monitoring is key to understanding whether your cache is working effectively and whether there's a cache hit or a miss. A cache hit happens when requested data is found in the cache, which saves time and avoids a database query. A cache miss occurs when the requested data isn't in the cache, requiring the database to provide it. Tracking these events helps measure your cache's performance. For example, imagine you're troubleshooting slow page load times on your e-commerce site, and you suspect issues with caching. By logging cache hits and misses, you gain visibility into how often data is being served from Redis versus how often it falls back to the database. A log entry might record a cache miss for a specific key, indicating that the requested data wasn't found in Redis. In such cases, the application retrieves the data from the database and may then store it back in the cache for future use. These logs provide details like the key that was missed, for example, user:123:category, and the subsequent fallback action to fetch the data. Frequent cache misses could point to issues such as expired cache entries, misconfigured caching logic, or even missing data in Redis. By analyzing these logs, you can adjust your caching approach to reduce misses and improve both caching efficiency and overall application performance. In this video, you learned about how to store and retrieve data from Redis in a distributed caching setup. Understanding how to store, retrieve, and monitor your data in Redis equips you to build fast, reliable, and scalable applications. Redis isn't just about caching, it's about delivering seamless, consistent experiences for your users.
In this lab, we're going to configure Redis caching in a .NET application to manage data across multiple servers. In step one, we're going to configure Redis in a .NET application, and I have a web API app here in VS Code, and I'm going to configure Redis to use in this application. I've got Redis running in the Windows subsystem for Linux, and we're actually running a Linux instance inside of Windows here. So you can see that's a Linux prompt. The Redis server is running in this Linux instance. So I can test this by running the Redis client, and we can send it a ping to see if it's actually running. So I'll ping it, and it responds with Pong. So when it responds with Pong, we know that the Redis server is running in this Linux instance. We can also see that it's running on port 6379, which is important. That's the default port for Redis when we install it. We just leave it the default port, and then we can make calls to the Redis server on that port. Exit out of the client, the command line interface, and we'll go back to our application. So now that we know Redis is installed and working, now we can interact with it. We're going to use the Stack Exchange Redis library that's part of the .NET framework. You have to install this separately. I've installed this already in this lab. If we go to our CSproj file, we can see that the Microsoft.extensions.caching.stackexchange Redis library is installed. And so now we can use that in our application. The first thing we're going to do is add a reference. We've got a reference here in our builder to the Stack Exchange Redis library, and we're going to pass in a couple of options. The first one is the configuration, which is just the domain and port that the Redis server is running on. Here we have localhost, and the server is running on port 6379. And then we're just going to give it an instance name called Redis Event Cache. Step 2, we're going to store event data in the Redis cache itself. To do that, I went ahead and created a post route. So the first thing I've done here is set up the rest of our Web API application. And then after app.run, we set up a controller, and we have to put that inside of a class. So we've got the API controller keyword, a route called controller, and then we're creating a class called event controller. And I've set up a read-only variable for iDistribution cache called _cache so that we can use that to post to and read from the cache. And then I have an event controller method. I pass in the cache information, and it sets our private variable to whatever data that I've passed into that method. Now for this step, we're going to use the post route called store. So we can hit that route and post data to the cache using that route. We've got an async task called store event, which will grab data from the body and post that data to the cache. So the first thing you want to do is serialize the data that's being passed in. So we'll pass in a JSON package in the body when we make that call. We're going to serialize that data. So you can see we're passing in event data and then serializing it using JSON serializer.serialize. And so that populates the serialized data string with that serialized data. We essentially create a byte array called data out of that serialized data. And then we're going to create some options for our distributed cache. This is the options that we're going to use in the cache itself. And this is an expiration time. So here we have 10 minutes. Now what this does is it creates a 10-minute expiration for the cache. So once we've populated data into the cache, we're going to give it 10 minutes. And then after that time, if a client tries to read from the cache, that data will have expired and they'll have to get fresh data. So a cache is really good for minimizing API calls or requests to a database. But if you have data that changes a lot, you'll want to make sure that expiration is timed correctly. So sometimes you refresh data once a day. Sometimes you refresh data more frequently, or maybe never. If you very infrequently refresh data, you can make your expiration fairly long without any problems. So we're going to create that expiration for 10 minutes. The await _cache set async is where we're actually sending the data to the cache. So we've got 3 items here. Key, which is just the name of the cache item that we're creating, the data that we're sending to it, and then any options that we've set, which is the expiration time. So by using that method set async, we're actually posting to the cache at that point. In step 3, we're going to have a route to retrieve the data from the cache. So here we have our HTTP GET, It's at the retrieve path for the route, and we're going to pass in the ID. In the store, we're actually sending an ID number in that JSON package to set the data for the cache. And in here, we're retrieving it using that ID number that we created in the store route. So here we're calling this, it's an async method, we're calling it retrieve event, and we're going to pull the event data out. So it's looking at the event ID that we passed in. And then here's where we're attempting to get the data from the cache. So we use that byte array again called cache data. It's an async call, and we're trying to get async using the key. So all we're doing is passing the key in to this get async method, which is what we're using to try to retrieve the data from the cache. The next line says that if the cache is not null, then we're going to deserialize that data. We're going to create this event data string and deserialize the data that we got from the cache. And we're going to return OK, meaning that the call was successful, and it will return the event data with that. So you can see here we don't have to make any calls to a database. We don't have to populate that string with any data in the program itself. We just pull it from the cache because it's available to us. Now, if the data is not in the cache, then we return not found. That's the event type. The data is not found, and we didn't find any event data in the cache. In a real-world scenario, we might go out to a database or call another API to retrieve the data that the user is asking for. In this instance, we're just returning not found. So that's how you can use a Redis cache, and this lab shows how to set that up in a very simple way to put data to the cache and retrieve data from the cache.
Efficient systems rely on more than just speed. They also need to keep data accurate and relevant. Cache expiration policies are the silent force ensuring your favorite websites and apps balance performance and reliability. In this video, we'll explain the key types of cache expiration policies and their use cases. Let's begin by exploring some key cache expiration strategies, starting with the absolute expiration, the simplest way to manage cache data. Absolute expiration means data is set to expire after a fixed amount of time, no matter how often it's accessed. This strategy works well for data with a predictable lifespan, such as session tokens. Session tokens expire after a set time and enhance security by logging out inactive users and preventing unauthorized access. For example, a session token might be issued for 30 minutes when you log into a website. After that, it expires, ensuring you're logged out if inactive for too long. Now, let's explore sliding expiration, a dynamic approach that adapts based on data use. Sliding expiration resets the expiration timer after each time the data is accessed, keeping it active as long as it's in use. This approach is ideal for user-specific data that remains relevant while being actively used, like a shopping cart or an e-commerce site. For example, imagine you're shopping online and adding items to your cart. With sliding expiration, your cart always stays active as long as you keep interacting with it. Every action resets the timer so your selections don't disappear while you're browsing. Finally, let's explore dependent expiration, which focuses on keeping cache data consistent with changes in related information. Dependent expiration occurs when cached entries are invalidated automatically if related data is updated or removed. This strategy ensures users always access accurate information, making it essential for scenarios like inventory systems. For example, in an inventory system, if a product's stock levels change, the cache updates immediately. This ensures customers always get the correct availability and prevents them from ordering out-of-stock items. In this video, you learned about the key types of cache expiration policies and their use cases. Cache expiration strategies like absolute, sliding, and dependent expiration keep systems fast, trustworthy, and up-to-date for users.
In this screencast, we're going to demonstrate how to implement and test expiration policies using iMemory Cache and Redis in .NET. We have three separate methods to show three different approaches to managing cache expiration. The first is to use set options to specify an absolute expiration in iMemory Cache, that object. The second is to implement logic to reset expiration with access. And then the third method will show how Redis dependencies can trigger cache updates. So let's look at the first method. We've got our absolute expiration here, and we'll look at the cache absolute method. The first thing we're doing is using a memory cache, which is a library that we can use just to set an in-memory cache for our cache options. We're going to set a key, which is absolute key, and a value, which is cache data with absolute expiration. This is the key value pair that we're going to pass into the cache and store in the cache. These are just two string values. Then we're going to create a new object, memory cache entry options, and set that to the variable cache entry options. And we're setting an expiration of 5 seconds. So that's our absolute expiration. You can see that property dot set absolute expiration, which means when that 5 seconds expires, then the cache expires. There's no reset. The data in the cache is deleted. So then we set our cache to the key value pair plus the expiration, the cache entry options, and we write out to the terminal. Our value is going to be written out based on the key that we pass in. The next line just will sleep for 6 seconds, which is after the time span that we set for the cache expiration. So the cache should have expired by then. And then we're going to write out what we see after the expiration happens. Either we're going to see the cache value, which should be this line cache data with absolute expiration. If it has expired, then we should see cache expired. So I'm going to go ahead and run this. So we see that we stored that value in our key value pair, cache data with absolute expiration. And then after expiration, we see that the cache indeed has expired, which is what we expect. All right, let's look at our second method. This is a sliding cache. A sliding cache we're going to set up pretty much the same way. We've got the key value pair, but instead of using the absolute expiration, you can see that on the memory cache entry options, we have the dot set sliding expiration, which is 5 seconds. So that will essentially slide the expiration for the cache. As we work through this for next loop, it goes through 3 seconds, pauses for 4 seconds in the middle. After the loop is finished, then we'll sleep for another 6 seconds, which is after the 5 seconds we set for the sliding expiration. And then we'll write out whether we either can get the value from the cache or whether the cache expired. We should be able to get the cache each time we go through the loop because we have set that sliding expiration on the cache. So I'm going to comment out the absolute cache method and run the sliding method. All right, so the first time through the loop, we see our string cache data with sliding expiration. Same thing the second time through and third time through. Wait for 6 seconds. And now after the expiration, we see that the cache indeed has expired. So we're able to get that data from the cache for those 3 times through the loop, and then it expires after the loop's complete. Now the third method is using Redis. So here we're going to use a Redis database to store items in the cache. We have 2 items we're going to put in the cache. That's set by db string set async. We have a parent key, which is product, and then a child key, which is inventory. For the parent key, we're going to insert product data for that cache item. For the child key, we're going to insert inventory data. And we're going to write those out just to show that we have them in the cache. And you can see we're calling db string get async and passing in that key. And that's going to return whatever the cache is holding. Then we're going to update the parent. So we have db string set async parent key again. And we're going to insert for that parent key updated product data. The next line, the if, will nullify what the child key, and you can see if the string get async parent key equals a certain value. On that child key item that's in the cache, we're going to delete that child key. We can actually invalidate the child based on an update to the parent. The state check will write out to the console what the parent is, and then we're going to try to get the value of the child key. In this construct here, if the child key does have a value, we'll see what's in the child key. Otherwise, it should return cache expired. Now, based on how we're using Redis in this context, we should see cache expired because we're removing it. We're deleting that key when the parent gets updated. So I'm going to comment out my second method and uncomment the Redis method. I'll go back down here and let me clear out my terminal. And now when we run this, we have the parent and the child both added to the Redis database. When we update the parent, we're expiring the dependent entry, which is our child entry. We've updated the parent with updated product data. So that's the new string that we added to the parent item. And when it tries to retrieve data for the child, you can see that the cache is expired, which is what we'd expect down here because we have deleted that item. In this screencast, we can see 3 different ways that we can implement cache expiration in the .NET framework, and each context or each approach has different purposes depending on what you're trying to accomplish in your app. In this lab, we're going to implement cache expiration policies in a .NET application to manage data freshness effectively. Got a simple console .NET application here. And in step 1, we're going to implement absolute expiration. So in this application, we're using the extensions.caching.memory library as well as the stackexchange.redis library. The stackexchange.redis library I installed separately, and we have Redis running in the background so that we can interact with Redis. Redis is running in the Windows subsystem for Linux and this computer. So this is actually a Linux instance running within Windows. And we can test for our Redis server running in the background by using the Redis client, the command line interface. And then I can ping it. And if it responds with Pong, then we know that the Redis server is running in the background. And you'll also notice that it's running on port 6379. So that's the port we'll interact with the server on. So get out of the command line interface, and we'll go back to our application. So in step 1, we're going to implement absolute expiration, which means this is the time that the cache will expire regardless of what happens. We're not going to set any conditions on that expiration. So the first thing we do is set up our method here. I've just got 3 methods to illustrate how this would work in an application. But we'll set up our cache variable using the memory cache object. And we're going to pass in some options when we set up that cache. So we've got the cache variable, we've got a session key, which is the key we're going to use to identify that specific instance in the cache, and then the data that we're going to pass into the cache that we're going to store. So the options that we're going to pass in is to set an expiration. You'll notice that we have memory cache entry options method, and then we're going to set absolute expiration with a time span of 5 minutes. So what this means is that the cache will always expire. This specific cache item will always expire in 5 minutes regardless of what else happens. And so we can't extend it. It will always expire. So you can think about a scenario where you always want to make sure that data is fresh. This absolute expiration will give you that. And then we use cache.set to pass in the key, the data, and the options to our cache and store it there. So then we write to the console that the session was stored. We sleep for about 5 minutes and 10 seconds. And then we can see what happens after the cache has expired. The cache item would be empty. If we tried to retrieve it, it would not allow us to get that data. So this is an instance where we absolutely expire that cache after a specific time, in this case 5 minutes. In step 2, we're going to implement a sliding expiration. So we'll go to the next method here, sliding expiration. A sliding expiration is one where we can actually extend the amount of time the cache has to expire based on when it's been accessed. So each time the cache is accessed, it increases the expiration by a set number of minutes in this case. So here we're using a memory cache again, set up the same exact way as the absolute expiration, except in this instance, the cache entry options is set to .set sliding expiration, and the time span is from 3 minutes. What this is telling the application is that if the cache is accessed, bump up the expiration by 3 minutes. And that's what we do in this loop here. We have a timer that we're going to set for an n number of minutes, and then the cache is going to be accessed. So we're going to use cache.get using that session key, so that's the identifier. And every time that happens, the cache expiration is reset for 3 minutes. 3 minutes are added to the expiration. So you can imagine a scenario where as long as people are accessing the cache, you want to leave it active. After a certain set amount of time, you want to release the data from memory and the cache will go away. And that's when you'll repopulate it. If someone needs that data, you'll repopulate it from a database or an API call. This allows you to effectively manage data that's being actively needed and then release memory from the system and free up resources when that data is no longer being accessed very frequently. Then we set another timer at the end here just to illustrate some time passing, and then we show that the cache has expired. So that's the sliding expiration. We use the cache.get, by the way, to attempt to retrieve data from the cache. And if that fails, we have the condition here. If we can get the data, we show it. If not, then we just write session expired. In step 3, we're going to implement dependent expiration, and we're using Redis for this illustration. Here we're going to actually have two things that we're going to store, two strings we're storing in our Redis cache. And the situation is if one of them expires, we want the other one to be deleted so that they're not out of sync. So we always have the same data kept in sync. So here we're setting up our Redis environment. We're using connection multiplexer to connect to the local host. We're going to grab the Redis database there, stored in the DB variable. And then we have two keys actually. So we've got the session key and the history key. And these are two separate items that we're storing in the Redis cache. In the next lines, we're writing to that Redis DB by using DB string set async. And in the first one, we're setting the session key with the data item session active. And the second is the history key with the login timestamp. So these are two separate items of data using those keys to identify those data items. If the session key does expire, if it's no longer available, we don't want the data in the history key item to be lingering. So we want to make sure that's a dependency and that one is removed when the other is expired. So the first thing we're going to do here now, just this is all for points of illustration, we write out to the console, and then we send that key expire async command, that method called db.keyExpireAsync, and we're passing in the session key, and we're giving it its specific time limit. So now we're setting when that key should expire, and it should expire 5 minutes from when it's put into the database. And then we're going to sleep for a number of minutes. This is 5 minutes and 10 seconds. We're sleeping here. And that's just to show that the session key will have expired after the sleep command runs out. So after 5 minutes and 10 seconds, then we're going to know that session key should no longer be in the cache. So we'll try to test to see whether that key is still there. And we do the await, which is a async call, db.keyExistAsync, and we're going to test and see if that session key is available. If it's not, then that's what the exclamation point means. If it's not available, if the test fails, then we also want to delete the history key, db.keyDeleteAsync. So we're going to delete the second item in the cache, and then we're going to write the session expired and the login history is deleted. So this is where the dependency comes in. So we can do the test in this line, this if statement, and then if the test fails, then we can delete the second one in the Redis cache. So these are three different ways that you can manage session data and cache data using an in-memory cache or Redis cache. They both work similarly, it depends on your needs, but you can manage the cache in various ways depending on the scenario that you're trying to meet.
Caching is a powerful tool for improving application performance and scalability. From in-memory and distributed caching to managing expiration policies, these strategies enable you to optimize efficiency while maintaining data reliability and freshness. We began by exploring the core principles of caching and its vital role in improving application performance and minimizing unnecessary operations. Next, we examined caching strategies, compared in-memory and distributed caching, and determined when each approach was most beneficial. Then, we focused on implementing in-memory caching, taking practical steps to store and retrieve data efficiently within an application. After that, we examined distributed caching systems, highlighting their role in maintaining performance and scalability across multiple server applications. Finally, we examined cache expiration policies, focusing on strategies to balance data freshness and performance while effectively managing cache lifecycles. Mastering caching techniques is essential for optimizing application performance and scalability. These strategies can enhance efficiency, ensure data reliability, and support seamless functionality in modern applications. Welcome to Optimizing Database Queries. This module covers key techniques to improve database performance, from indexing strategies to optimizing complex queries. By the end, you'll be ready to enhance efficiency and scalability in your applications. We will begin by exploring the foundational principles of query optimization, focusing on how efficient queries improve database performance and resource management. Next, we will examine indexing strategies and learn how to structure and organize data effectively to accelerate query execution. Then we'll apply practical indexing techniques, demonstrating how to implement them to enhance query speed and reduce processing time. After that, we will analyze and refine complex SQL queries, identifying inefficiencies and implementing strategies to optimize their performance. Finally, we'll identify best practices for query optimization, ensuring you can consistently design and maintain high-performing database queries. By the end of this module, you'll have the tools and strategies to optimize database performance and scalability with confidence. Let's get started. In database management, the efficiency of your queries directly impacts system performance. Optimizing queries reduces resource usage and ensures your applications remain responsive and scalable even as demand grows. In this video, we'll define query optimization and its characteristics. Let's begin by defining query optimization and exploring its key elements. Query optimization is the process of improving how efficiently a database process queries by minimizing resource usage, for example, execution time and server load. While caching temporarily stores data for faster access, query optimization focuses on refining how the database retrieves data to ensure the process is as efficient as possible. Now let's explore the specific steps that make query optimization effective. The first step is to analyze the query by evaluating the query's execution plan. A query's execution plan is a detailed set of instructions that outlines how the database will retrieve the required data. Tools like the explain statement in MySQL or the include actual execution plan option in SQL Server Management Studio reveal these steps. These steps help determine whether the query uses indexes or scans an entire table. By analyzing the execution plan, you can identify opportunities to enhance performance. The next step is indexing, which is a powerful technique for speeding up queries. Indexing is the process of creating a data structure, often a B tree or hash table, that improves the speed of data retrieval operations in a database. An index acts as a shortcut, allowing the database to locate rows more efficiently without scanning an entire table. It's like creating a reference guide for your data, making it easy to locate a specific piece of information. For instance, an indexed email column allows the database to pinpoint the record quickly if you're searching for the customer by their email address. Without an index, the database must examine each entry individually, which takes much longer. The next step is to apply cost-based optimization. With cost-based optimization, the database evaluates multiple execution plans and selects the one that consumes the fewest resources like CPU or memory. For example, it might choose to use a pre-computed result instead of recalculating the data, saving both time and resources. Finally, the optimization joins to combine data from multiple tables, which can be resource intensive. Joins are operations that combine rows from two or more tables based on a related column, enabling you to retrieve meaningful data spread across multiple tables. They are essential for working with relational databases, where data is often normalized and stored in separate tables to reduce redundancy and maintain consistency. Optimizing joins ensures the database performs fewer operations, improving overall query speed. For example, filtering smaller datasets before joining them makes the process more efficient, and a join reduces unnecessary computation. In this video, you learned about query optimization and its characteristics. By analyzing execution plans, leveraging indexing, and refining operations like joins, you can unlock significant performance gains that benefit both developers and end users alike. Query optimization is a precise process that ensures databases handle queries efficiently and effectively. From validating query structures to evaluating resource costs and carrying out the plan, each step of automatic query optimization is vital for delivering accurate results quickly. In this video, we'll explain how query optimizers select execution plans. Let's begin by examining the steps of implementing automatic query optimization, starting with parsing. Parsing ensures the query is structured correctly so the database can understand and process it. For example, parsing checks that all parts of the query, like the requested action and the data source, are clearly and properly specified. Without this step, the database wouldn't be able to interpret the request or proceed to the next stages. Once parsing ensures the query is valid, the database must determine the best method to retrieve the requested data, otherwise known as cost calculation. Optimizers are typically used to formulate the cost calculation of any given query. In the context of databases, an optimizer is a component of a database management system that determines the most efficient way to execute a given query. The optimizer evaluates different query paths and selects the one that minimizes time and resource usage. For instance, imagine you want to find users over 30 years old, and the database has an index on the age column. The optimizer decides whether to use the index to locate rows quickly or scan the entire table. After the optimizer chooses the most efficient plan, the database moves on to the final step, execution. Execution is the step where the database retrieves the requested data using the plan chosen during cost calculation. If the optimizer decides to use the index, the database retrieves only the relevant rows quickly. If it selects a table scan, the database processes every row to find matches. In this example, you learned how query optimizers select execution plans. Query optimization is crucial because it minimizes the time and resources required for a database to process queries, ensuring faster performance and reduces server load. Efficient queries help maintain application responsiveness even under heavy traffic, while conserving infrastructure costs. Databases store vast amounts of information, and without the right tools, retrieving even a single piece of data can be incredibly slow. Indexing transforms the chaos into order, enabling fast and efficient searches that are crucial for performance optimization. In this video, we'll describe indexing and its role in query optimization. Before we begin exploring the elements of indexing, let's examine its fundamental unit, an index, and why they are essential for optimizing queries. An index is a data structure that speeds up query performance by organizing data to make it faster to retrieve. Think of it like the index in a book, which helps you quickly find the page where specific information is located. For example, in a contact list, the data may be stored in the order you add context, but an index allows you to find people more easily by listing them alphabetically. Similarly, retrieving all customers in a particular country, like Canada for example, is quicker with an index on the country column in a database rather than searching through every row of the data. Now that you understand indexes, let's explore some key elements in the indexing process, starting with clustered indexes. A clustered index is a type of index that sorts and stores the data rows of a table based on the values of the index key, which is usually the primary key. This means the data rows in the table are organized according to the index key, like books arranged on a shelf in a library by a special code, like their ISBN number. Clustered indexes arrange the data for fast access. But what if you need to search by something other than the order of the data? Well, that's where non-clustered indexes come in, offering a different way to organize and retrieve information efficiently. A non-clustered index points to memory addresses instead of storing the data. Imagine the index at the back of a textbook. It lists topics and tells you the page number where you can find them. making it easy to locate information without flipping through every page. Similarly, a non-clustered index in a database points to the data's location in a particular data set. For example, if you have a database of products and you create an index on product name, you can quickly find items by their name, even if the actual data is stored in a different order. Now that we have explored different indexes and how they help optimizing querying, let's examine a couple of use cases. One illustrating how indexes can improve performance, and one demonstrating possible trade-offs of using indexing. Indexing helps to improve search speed. For example, if your application frequently retrieves all orders related to a specific customer, an index on customer ID ensures the database can retrieve that information directly and quickly. However, while indexes may speed up searches, they can cause slowdowns for inserting and data updates, because the index must also be updated. Additionally, for bulk inserts, it may even be necessary to temporarily disable indexes to avoid performance issues. Once the insert is complete, you can re-enable the index to ensure optimal performance during data loading. In this video, you learned about indexing and its role in query optimization. Indexing is a powerful tool that can be used to increase the performance of queries, ensuring your applications run smoothly as they're meant to. Indexes are essential for improving database performance, but they come with trade-offs that can't be ignored. While they make queries faster, they also introduce challenges like increased storage needs, slower write operations, and ongoing maintenance. In this video, we'll explain the trade-offs and challenges of indexing. To appreciate the challenges of indexing, it's essential to understand that it changes how databases operate and the trade-offs made when implementing these tools. Let's begin by exploring the trade-offs made when using indexes. Indexes are important for improving read performance in databases. Recall that indexes act like a table of contents in a book, allowing the database to retrieve or read specific records faster without scanning every entry. This is particularly valuable in applications like social media platforms, where users expect posts and updates to load instantly. But indexing isn't all about speed. Write operations such as adding, updating, or deleting data take longer because the database must update the index alongside the data. This trade-off between read and write performance is one of the core challenges of indexing. The benefits of faster reads come with another consideration: increased storage costs. Indexes require additional storage space since they create new data structures to organize the database. For example, imagine a news website managing millions of articles. Indexing can speed up searches like breaking news or sports updates, but each index increases the data stored on servers, increasing storage requirements, particularly as the database grows. Balancing the need for quick searches with the cost of extra storage is a key part of designing an efficient database. While indexes can improve performance, adding too many can have the opposite effect, often known as over-indexing. Over-indexing happens when a database includes unnecessary or excessive indexes, reducing performance and complicating maintenance. Consider a video streaming platform that indexes every possible attribute: titles, genres, release years, actor names, and more. Adding new content could slow down updates significantly, making the database harder to manage and impacting overall performance. A well-designed indexing strategy focuses on the most relevant columns. For instance, an inventory management system might prioritize indexes for product names and categories, as these are commonly searched fields. However, indexing less used fields like supplier details would only add overhead without meaningful benefits. By targeting frequently accessed columns, databases stay fast and efficient without unnecessary complexity. Regular monitoring and optimization are essential to ensure indexes remain effective over time, especially since databases are dynamic systems that change as their user behavior changes. Query logs, which track the most frequent searched fields, are invaluable for identifying performance bottlenecks. For example, a music streaming app could use query logs to determine that genres like trending now are searched more often, ensuring those fields are indexed for quick response times. Now that you understand some of the trade-offs and challenges of indexing, let's bring these concepts together with an example. Imagine that a content management system initially improved performance by indexing frequently searched fields like blog titles and categories. Over time, however, they added indexes for less critical fields like author bios. This slowed updates and consumed more storage. Reviewing query logs, the system administrators identified and removed unnecessary indexes, and this restores speed and storage efficiency. In this video, you learned about some of the trade-offs and challenges of indexing. With careful planning and regular monitoring, you can create fast, efficient databases that meet user demands while maintaining long-term performance.
In this screencast, we're going to demonstrate how to create clustered and non-clustered indexes in SQL. So I have a terminal window open here, and the first thing I'm going to do is log into MySQL, the MySQL command prompt. So we're going to create a database called InventoryDB, and then immediately use that database. All right, so we created a database, InventoryDB, ran the command use InventoryDB, and so now we're in the database, so we can start to manipulate it. The first thing I'm going to do is create a table called products, and it's going to have a product ID, a product name, category, price, and a stock item. All right, so we have our table created, and I'm going to populate it with some sample data. Now, we're not going to have a lot of sample data for this demo, so the indexes will only be marginally useful, if useful at all, but we can still examine how we can use and create indexes. Indexes are really mostly powerful for large amounts of data. You can see we only have a few records here. We can still see how indexes can be created and how we can actually monitor how they work, even though they're not going to have much of an impact in this screencast. So the first thing I want to do is turn profiling on, and the reason I do that is so that we can see the performance before and after. We won't see much here, but this is how you can actually watch the performance of indexes as you create them. Okay, so the first thing we're going to do is create a primary key. Now we're going to get an error here because when I created the table, the creation process actually already created a primary key. We can't have two primary keys defined, but if you don't have a primary key on your table, that command alter table and then the name of the table, add primary key, and then whatever field you want to use as your primary key will create a primary key for you. But in this case, we already had one, it returned that error. Now I'm going to do a simple select query. We're going to select all records from products where category equals electronics. All right, and that returned 3 records. So we've got 3 records in our table or in the category of electronics. And now I want to show the profiles that we have in our log. So we turn the profiling on, and now we can show those profiles, and you can see how long these queries are taking after we do them. So this is a good way to monitor whether your indexes are actually improving things. So we created our alter table that took 8 1,000ths of a second, and then the select query was 9 1,000ths of a second. These are very fast moving queries because we don't have much data. We're not working with much data, and our queries are very simple. Now I'm going to analyze the execution plan to see if the queries are actually using the index. So we can use this explain command. So we're going to run that query again, but we're going to output some information for us so we can monitor how those queries are running. This is a table that shows what we're looking at in terms of the output. These are the rows across the top, and then this is the data. We're mostly interested in this column here. So this says the type, and it's showing the type as all, which means that it's actually not using any index at this point. It's just the table is so small, it's just faster for MySQL to analyze the entire table than to use an index to look up this category equals electronics. Now, as you add more data and as you get into lots of records, the type should shift to showing the index, and that index is actually being used to perform those queries. That will help improve performance as you go along. Now I'm going to create a non-clustered index called IDX category on products. So we're using the create index command. We're going to call it IDX category, and we're putting that on the products table in the category column. Okay, so the query ran, and now we can see that index was created. Now I'm going to run my select query again, and I'm pressing up arrow on the keyboard to run that select query one more time. There's the output. Now let's show the profiles again. We ran the select query twice. The first time it was 9/1000ths of a second. Now it's up to 1/100ths of a second. And the reason for that is because, again, we don't have a lot of data here. So it's actually faster for MySQL to query the entire table than to use the index. If we run this again, the ref is IDX category. So it actually used the index in this case. It was a slower query because it used the index. It's actually faster on a smaller table just to not use the index at all. That's an important thing to realize as you're creating indexes. There's a certain point where they don't really have much impact, and you can use these commands to improve the performance of your queries based on how large your data set is. Now I'm going to create a composite index. So I'm going to drop the existing index we have on the table. So we're going to delete, essentially. Drop means delete that IDX category and products. So that removes that index. And now composite index is where we're creating an index on two separate fields. So it's still going to be on the products table, but we're creating an index now called IDX category price on products in the category and the price field. So now we have an index on both of those fields. And I'm going to run a select statement. That's a compound select statement where we're going to have two criteria for this query. So we have the category equals electronics, but we want only those products where the category is electronics and the price is less than 500. So we'll run that. And then we've got a price 20 and 50, mouse and keyboard, and there's two that returned on that one. Now we're going to look at this again. We're going to have it explain this query and to see whether it used the index or not. So there we go. So it did use the index. It's got this type of range, and the key that it's using is IDX category price, which is that index we created. So it is using that index to look up this data. Now again, whether that's faster or not is going to be part of the profile. So if we do show profile again, we can see how fast these queries are performing. So there we go. We have these queries are obviously very fast because they're quick queries on a small table. But as you add data, you can, again, monitor this using this profiles command to see how your indexes are doing. So these are ways that you can create indexes in MySQL and monitor their performance over time. You can actually have scripts that will run overnight as you add data, output a log to see how your queries are performing as data is added over time. And you can drop and add indexes as needed based on the size of your data set.
Indexes are a powerful tool for improving database performance, but measuring their impact is essential for using them effectively. By analyzing execution time, monitoring resource usage, and reviewing query execution plans, you'll gain the skills to optimize queries and enhance the efficiency of your applications. In this video, we'll evaluate the effectiveness of indexes by analyzing query performance metrics. Let's begin by examining some metrics for evaluating index performance. The first metric in evaluating an index's effectiveness is measuring a query's execution time. Execution time refers to the total time it takes for a query to complete. This provides a performance baseline to compare improvements. The query setStatisticsTimeOn enables timing statistics for all subsequent queries within the same session. Once enabled, you don't need to run it with each query. It will automatically provide execution time details for every query executed after it. This means that after running the next query, you will get detailed timing information in the output, including CPU time or processor power used, and elapsed time or total time taken. To illustrate how execution time can be measured, consider this example query. Select asterisk from orders where order date between 2024-01-01 and 2024-01-31. This query retrieves all rows from the orders table where the order date is between January 1st, 2024 and January 31st, 2024 inclusively, combined with setStatisticsTimeOn. This query allows you to capture execution metrics before implementing any indexing changes. Once you've measured execution time, the next metric you want to assess is resource usage by analyzing the impact of indexing. Resource usage tracks the amount of CPU and memory a query consumes during execution. Indexes improve resource usage levels by allowing the database to locate rows more efficiently, especially for frequent searches on the indexed column. For example, the create index command creates an index named IX order date on the order date column in the orders table. This index is especially useful for improving the performance of frequent searches or filters on the order date column. After creating an index, you then rerun the query and observe the results. Reduced CPU and memory usage indicates the index is optimizing query execution. You can use tools like SQL Server's Activity Monitor to track these improvements. To ensure the index is being applied effectively, you'll also need to review the query execution plan. A query execution plan details the steps the database takes to retrieve data. By analyzing these plans, developers can identify inefficiencies like full table scans, unoptimized joins, or missing indexes, enabling them to fine-tune queries for better performance. For example, using MySQL Workbench, you can examine the execution plan for your query. Once the query is executed, you can view the execution plan by selecting the Execution Plan tab at the bottom of the results window. If you get unique key lookup as a response, it means the database is efficiently using an index to locate a specific row or set of rows. If you get full table scan, the database still scans all the rows and adjustments to the index might be needed. After confirming the index's impact, it's time to clean up by disabling query timing information. Disabling query timing ensures future results are not cluttered with additional information. The query set statistics time off disables the display of detailed timing information for subsequent queries in the session. This means the CPU time and elapsed time statistics will no longer appear. In this video, you learned about the effectiveness of indexing by analyzing query performance metrics. Analyzing metrics like execution time, resource usage, and query execution plans empowers you to refine your indexing strategies.
Managing security on your website will help make your data and your users more safe. In this lab, we're going to implement encoding and sanitation techniques to prevent cross-site scripting or XSS attacks in a sample web application. In step 1, we're going to implement HTML encoding. I've got a simple node.js website here in Visual Studio Code. And this website has a simple input form. So you can imagine this is a place where users can enter comments. So we have an input field called user input, a button where they can submit the form, and then a div that displays any output. When the user clicks the button, it runs this process input function. And we're going to do 3 different things in this function. But for this one, we're going to concentrate on this first section. The first thing we do is grab the input from the user input field up here at the top. We're placing it in the value input. And then the first thing we're going to do is encode any HTML. That means rendering any HTML tags as plain text. By encoding it, the HTML becomes less dangerous. It just becomes a text field rather than actual HTML when we render it to the screen. How we're going to do that is to take that input and we're going to create a temp div, which is essentially a div element that we're going to hold in memory. And then we're going to assign the input value to that div element, but we're going to use this text content property. By using the text content property, it just renders whatever's in that input to text. So it essentially encodes it for us by using that property. Once it's encoded, then we can also output it, so we can get the output element and also set its text content property to the tempdiv.textContent. The way that we're encoding this is by using that text content property, so we don't have to do any manual encoding. In step 2, we're going to implement JavaScript encoding, and we're going to use regex to do that. So again, we're taking that input that we're grabbing here at the beginning of the function, we're assigning that to safe input, but we're going to use this replace function to go through and look for any code that we don't believe is safe, and we're going to put a slash in front of it. It's called escaping characters. So we can escape it so that it renders it as text in the output rather than displaying it as anything that could cause harm, like a script or any HTML that we don't want it to render. By using that
replace with regex. We can escape anything that we want to escape there, and then the output will be rendered safe. The third thing we're going to do is in step 3, implement URL encoding. So here we're going to encode any URL elements, so they are also rendered safe. We're taking that input variable again, and we're going to use this encode URI component function against the input and assign it to encoded URL. So that function will do all the work that we need it to do for us to encode that URL that's being passed in, if there is one. And then we're just going to put output to the console in the browser, the encoded URL using that variable. So these are 3 different ways that we can encode different aspects of whatever the user happens to pass in. In a real-world application, you might run the input through all 3 of these so it catches any elements that you want to catch before using that input in any data manipulation or even putting it to the browser. In step 4, we're going to implement input sanitation with a library called DOM Purify. And DOM Purify will do a lot of work for you. So some of these items you don't have to do manually. We brought in DOM Purify in the header using the script tag. So this is a complete library that will clean up any inputs that you have. So here we're using that input variable again at the top that we're setting here. And we're going to call DOM Purify.sanitize. So it's a single function call that will go through and sanitize your input for you, removing anything dangerous. We're going to assign that to sanitized input and then output the contents of that variable to the log. Sometimes DOM Purify may remove too much or doesn't give you some visibility into the things that you want to have control over. So sometimes you want to do some of this work manually like we've done in step 1 through 3. But if you don't, if you just want to make sure that your input is clean and safe, DOM Purify is a great library to do that work for you. So these are 4 different ways that you can approach content and inputs on your website to make sure those inputs are safe and won't harm your data or your users. Now in step 5, we're going to optimize a join query. We're going to create that index and then we're going to examine it. So the orders table contains a customer ID column that acts as a foreign key, which links the customer's table. So let's suppose your sales team runs join queries to retrieve customer names along with all their orders. Creating a non-clustered index in the customer ID column in the orders table will improve the performance of those join queries. So that's the first thing I'm going to do is create that index. So now we have another index that does work alongside with the customer's table. And now I'm going to run this explain query to see how this select query would run against those 2 tables. I don't have a customers table. I didn't create one in this particular database, so we're not going to see any results. But this is how that explain keyword would work on a select query where you have a join on 2 tables. And then you can get the results back to show you how those would work. So these are ways that you can improve queries in MySQL. Most SQL databases have very similar commands, so you can create clustered, non-clustered indexes, explain how queries would run so you can see the results, and then you can do these join queries as well and optimize how they run as you're interacting with your data.
Databases hold vast amounts of information, but retrieving that data efficiently is where the challenge lies. Optimizing SQL queries isn't just about speed. It's about identifying bottlenecks in your queries and making your database more efficient so it delivers results with precision. In this video, we'll identify inefficiencies in complex SQL queries using query performance metrics. Let's begin by exploring common bottlenecks in SQL queries and how these can be addressed, starting with the full table scan, a well-known bottleneck. A full table scan happens when the database checks every row in a table, often due to missing indexes or poorly structured where clauses. For example, when you use select asterisk from products, the asterisk tells the database to retrieve all columns, even the ones you don't need. While this approach might work fine for small tables, it becomes inefficient for larger data sets. To avoid this, you can optimize the query by selecting only the necessary columns and filtering rows with a where clause. Now let's examine a query that would be more efficient for larger data sets. Suppose you want to retrieve the name and prices of products costing more than $50. This query filters rows using the where clause. The condition price greater than 50 ensures only products priced above $50 are included. Additionally, specifying name and price in the select statement reduces the data retrieved to just the necessary columns. However, this query can also remain inefficient without an index. For example, in this query, create index IDX price on products with price in parentheses. By creating an index on the price column, the database can quickly locate matching rows. Think of it as using a table of contents to navigate a book instead of flipping through every page. Another common bottleneck in SQL queries involves joins on large tables. When joining tables without proper indexing, the database compares every row in one table to every row in the other. This process becomes time-intensive as the size of the tables increases. For example, this query retrieves the ID from the orders table and the name from the customers table by joining them on the customer ID column. On large tables like an orders table with thousands of rows, this join can become a bottleneck if customer ID lacks an index. Without an index on customer ID, the database performs a full scan of all rows in both tables, comparing each row in the orders with each row in the customers. By adding an index using create index, the database matches rows much faster, significantly improving performance. Now that you understand how joins can become bottlenecks, let's explore temporary tables, another common bottleneck. These tables store intermediate query results, but can consume additional memory and slow down queries. For example, this query creates a temporary table named temp sales to store rows from the sales table with a quantity greater than 100. This next query calculates the average quantity of these filtered rows using the AVG or average function. While this approach works, it adds overhead by storing intermediate results in memory. Simplifying this process into a single query can avoid these inefficiencies. For example, this query calculates the average quantity of items sold, but only for rows where the quantity is greater than 100. The where clause filters the data, and the AVG function computes the average directly from the filtered results. By performing both operations in a single query, it eliminates the need for intermediate storage, making execution much more efficient. Nested subqueries are another structural bottleneck issue that can increase complexity and execution time. For example, in this query, for each row in the products table, the database evaluates the subsequent query to check if the product ID exists in the filtered results from the sales table. This repeated evaluation can be inefficient, particularly for large data sets. By rewriting the query as a join, the database retrieves all columns from the products table for items sold in quantities greater than 100. The join combines the products and sales tables using the product ID column, ensuring only matching rows are considered. The where clause further filters these results, selecting only rows where the sales quantity exceeds 100. This approach streamlines execution by handling the operation in a single optimized step. Now that we've reviewed some of the common bottlenecks in SQL queries, we must identify and address these issues using performance metrics. You can use explain plan to analyze queries. For example, the query explain plan for select name price from products where price greater than 50 generates an execution plan that outlines each step the database takes to retrieve the requested data. The execution plan highlights whether the database retrieves rows efficiently using an index or inefficiently by scanning the entire table. For instance, if the plan returns table access full, it means the database is examining every row in the products table because no index exists on the price column. This is inefficient, especially for large data sets. If the plan returns index scan, it indicates the database is using an index on the price column to locate the relevant rows directly. This optimization drastically reduces the number of rows the database needs to scan, resulting in faster query performance. In this video, you learned about inefficiencies in complex SQL queries using query performance metrics. Addressing inefficiencies like full table scans, slow joins, and unnecessary complexity can transform your database's performance. Are your queries working as hard as they should, or are they costing you valuable performance? By replacing subqueries, leveraging indexes, and optimizing joins, you can streamline database operations. These small changes can lead to faster queries, cleaner code, and more efficient systems. In this video, we'll demonstrate query optimization techniques such as rewriting queries, adding indexes, and adjusting joins. Let's begin by examining some SQL query optimization techniques you can apply. Rewriting queries for simplicity is one technique for optimizing your queries. This enhances performance and reduces server strain, providing users with a smoother experience. In many situations, this involves rewriting or removing subqueries. Subqueries, also known as inner queries or nested queries, are SQL queries embedded within another SQL query. They are used to perform intermediate calculations or fetch specific data needed by the main or outer query. Subqueries, while functional, require extra computation, whereas a properly structured where clause often achieves the same result more effectively. An example of inefficiency is a query that uses a subquery to find orders placed after January 1st, 2023 by matching order ID values between the orders and sales tables. The subquery is processed separately, which can make the query less efficient compared to direct filtering approaches. To optimize this query, it could be rewritten to directly filter rows in the orders table using the where clause to specify that only orders with a sales date later than January 1st, 2023 should be included. Eliminating the need for a subquery improves readability and performance, making the filtering process more efficient. Making sure that you are using indices effectively is another technique to optimize your queries. For example, this command executes an index on the product name column of a products table, optimizing how the database handles queries involving this column. Enabling direct searches with the create index statement significantly accelerates searches and avoids scanning the entire table, enhancing query performance. Another method to optimize your queries is avoiding temporary tables when possible. Temporary tables slow down performance by consuming extra memory. To solve this issue, we use common table expressions. Common table expressions, or CTEs, are temporary result sets in SQL that you can define within a query and reference multiple times in that same query. They improve code readability and modularity, especially for complex queries, by allowing you to create named reusable subqueries. For example, this query defines a common table expression named sales summary, using the with keyword to calculate the total sales amount from the sales table called total sales. Then, this select statement retrieves the total sales from the CTE in the main query. The CTE acts as a temporary result set that exists only during the query execution, avoiding the overhead of creating a temporary table and making the query more efficient and readable. Finally, let's examine how to optimize joins, especially when working with large data sets. Joins are essential for combining data from multiple tables, but they can be resource intensive when dealing with large data sets. For example, this query retrieves data from the customers and orders tables by matching rows where the customer ID values are equal. It uses aliases C for customers and O for orders to simplify table references, making the query more concise. The where C.isActive equals 1 condition filters active customers before performing the join, reducing the dataset size and improving the query's overall efficiency. In this video, you learned about query optimization techniques, such as rewriting queries, adding indexes, and adjusting joins. Techniques like these are essential for developers seeking to deliver high-performance solutions. Are your queries working as hard as they should, or are they costing you valuable performance? By replacing subqueries, leveraging indexes, and optimizing joins, you can streamline database operations. These small changes can lead to faster queries, cleaner code, and more efficient systems. In this video, we'll demonstrate query optimization techniques such as rewriting queries, adding indexes, and adjusting joins. Let's begin by examining some SQL query optimization techniques you can apply. Rewriting queries for simplicity is one technique for optimizing your queries. This enhances performance and reduces server strain, providing users with a smoother experience. In many situations, this involves rewriting or removing subqueries. Subqueries, also known as inner queries or nested queries, are SQL queries embedded within another SQL query. They are used to perform intermediate calculations or fetch specific data needed by the main or outer query. Subqueries, while functional, require extra computation, whereas a properly structured where clause often achieves the same result more effectively. An example of inefficiency is a query that uses a subquery to find orders placed after January 1st, 2023 by matching order ID values between the orders and sales tables. The subquery is processed separately, which can make the query less efficient compared to direct filtering approaches. To optimize this query, it could be rewritten to directly filter rows in the orders table using the where clause to specify that only orders with a sales date later than January 1st, 2023 should be included. Eliminating the need for a subquery improves readability and performance, making the filtering process more efficient. Making sure that you are using indices effectively is another technique to optimize your queries. For example, this command executes an index on the product name column of a products table, optimizing how the database handles queries involving this column. Enabling direct searches with the create index statement significantly accelerates searches and avoids scanning the entire table, enhancing query performance. Another method to optimize your queries is avoiding temporary tables when possible. Temporary tables slow down performance by consuming extra memory. To solve this issue, we use common table expressions. Common table expressions, or CTEs, are temporary result sets in SQL that you can define within a query and reference multiple times in that same query. They improve code readability and modularity, especially for complex queries, by allowing you to create named reusable subqueries. For example, this query defines a common table expression named sales summary, using the with keyword to calculate the total sales amount from the sales table called total sales. Then, this select statement retrieves the total sales from the CTE in the main query. The CTE acts as a temporary result set that exists only during the query execution, avoiding the overhead of creating a temporary table and making the query more efficient and readable. Finally, let's examine how to optimize joins, especially when working with large data sets. Joins are essential for combining data from multiple tables, but they can be resource intensive when dealing with large data sets. For example, this query retrieves data from the customers and orders tables by matching rows where the customer ID values are equal. It uses aliases C for customers and O for orders to simplify table references, making the query more concise. The where c.isActive equals 1 condition filters active customers before performing the join, reducing the dataset size and improving the query's overall efficiency. In this video, you learned about query optimization techniques, such as rewriting queries, adding indexes, and adjusting joins. Techniques like these are essential for developers seeking to deliver high-performance solutions. Imagine trying to find a single document in a room filled with scattered papers. Chaotic and time-consuming, right? Now picture having a well-organized filing system that gives you exactly what you need in seconds. Writing efficient SQL queries works the same way. In this video, we'll identify best practices for writing efficient SQL queries. Let's begin by exploring best practices for efficient query writing, starting with avoiding select asterisk. In SQL, the select keyword retrieves columns from, specifies the table, and where filters rows. Avoiding select asterisk means retrieving only the necessary columns instead of the entire table, which saves memory and boosts performance. For example, instead of retrieving everything from an employee database with the select asterisk from employees, focus on the data you need, like name and email, with select name email from employees. This way, you can reduce unnecessary data retrieval and keep your requests lean. Now that you've examined how to limit the data you're retrieving, let's explore how to filter it more efficiently using where clauses. Where clauses allow you to narrow down the results early in the query, meaning the database filters the data during query execution, minimizing unnecessary processing and avoiding full table scans. For example, if you're searching for active users in your database, filtering the results directly in your query is much more efficient. For example, In this query, the select clause specifies that only the username column should be retrieved. The from clause identifies the user's table. Finally, the where clause filters the results to include only rows where the is active column has a value of 1, representing active users. The query skips over inactive users entirely by narrowing down the database at the database level, meaning filtering happens within the database itself, improving efficiency and performance. To build on this, use the where clause to filter and avoid scanning entire tables and improve efficiency. For example, when generating a sales report, you can specify a date range to focus on recent orders. This query retrieves only the order ID and total for orders placed on or after January 1st, 2025, skipping irrelevant older data. Filtering data is important, but queries can get overly complex when dealing with the related tables, so it is important to limit subqueries. Remember that subqueries are queries inside other queries, and while useful, they often require more steps for the database to process. For example, a query can find employees in the sales department by matching their department ID with the ID of the corresponding department. The select statement then retrieves all columns from the employees table, and the subquery filters departments to find the ID of the one named sales. This ID is then used to match employees in the main query. While useful, subqueries often require more processing steps, impacting performance for larger datasets. Using a join allows the database to process the query more efficiently by directly linking related tables, reducing the overhead of nested queries and improving readability. For example, in this query, inner join connects the employees table to the departments table using department ID, and the where clause filters the results to include only employees in the sales department. Joins are a more efficient way to combine data, as they connect related tables directly, avoiding the extra processing required for subqueries. For instance, in this query, the inner join links the customers table to the orders table through the customer ID column, allowing you to retrieve each customer's name along with their total order amount in a single, streamlined operation. Joins are a powerful tool, but they can become inefficient if not used carefully, which is where optimizing joins comes in. Imagine you're managing student enrollments. You can use a join to connect students to their courses without pulling unnecessary data. For this query, the first inner join links the students table to the enrollments table using the student ID column, while the second inner join connects the enrollments table to the courses table through the course ID column. Optimizing the join by focusing only on matching rows ensures the query efficiently retrieves each student's name and enrollment courses titles without including extra data. However, to keep your queries efficient and focused, remember to retrieve only the data you need from joins. For example, if you're building a customer dashboard, you can limit results to recent orders by adding a condition to the join query. In this query, the interjoin connects the customers table to the orders table using the customer ID column, and the where clause filters the orders placed on or after January 1st, 2024. This ensures the query retrieves only the customers' names and order dates for relevant recent transactions, avoiding unnecessary processing of older data. Finally, once your queries are optimized, you will want to handle large datasets effectively using pagination techniques. Pagination breaks data into smaller, manageable chunks, making it easier to process and display without overwhelming your system. For example, if you're building an e-commerce site, you can load product listings in smaller parts rather than retrieving an entire table. In this query, limit 20 retrieves the first 20 rows, while order by name sorts the products alphabetically. This keeps your system efficient by processing only a subset of the data at a time. Similarly, pagination can be applied to a news site where articles are displayed page by page. In this query, offset 20 skips the first 20 rows and limit 10 retrieves the next 10 articles sorted by the most recent published date. This approach ensures the application remains responsive and user-friendly, even with large datasets. In this video, you learned about best practices for writing efficient SQL queries. By applying these best practices, you'll optimize performance, reduce resource usage, and create systems that handle data-intensive tasks with ease. Databases are the backbone of modern applications. Yet even the best systems can slow down without careful tuning. By understanding and implementing query optimization techniques, you can ensure that performance issues don't derail your success. In this video, we'll explain how to monitor and optimize queries over time. Before exploring the steps, let's define continuous query optimization and why it's essential for maintaining a high-performance database. Continuous query optimization involves monitoring and improving database query performance to ensure efficiency and scalability. While initial optimizations like adding an index can be done during development, real-world usage in production environments often reveals unexpected patterns. For example, in production, data volumes grow and users interact with the database in ways that are difficult to predict during development. Queries that weren't an issue in development may become slow under production workloads. Regular monitoring allows you to adapt to these changes and keep your database performing efficiently. Now that we understand continuous query optimization and its necessity, let's examine the steps for implementing it in your application, starting with monitoring query performance. Monitoring query performance involves tracking execution times and resource usage. This enables you to effectively identify and address slow-running queries. Using tools like SQL Profiler, a feature of SQL Server, provides detailed insights into query performance by tracking key metrics such as execution times, CPU usage, and I/O operations. This performance monitoring tool enables you to create trace sessions, capturing real-time data to analyze and optimize query execution effectively. With this tool, you can track which queries take the longest to run, identify delays caused by data retrieval or computations, and observe overall resource consumption. Once you've identified a slow-running query, for example, one taking 5 seconds to execute, SQL Profiler provides tools to analyze its performance more thoroughly. A key feature for this is the trace session, which captures detailed metrics about query execution, helping you pinpoint areas like resource usage and processing delays. You can create a trace session using the exec sp_trace_create command in SQL Server. This command creates several parameters: at trace ID output, which stores the unique ID of the trace session, 0, which specifies default trace options without enabling automatic file rollover, and c/traces/mytrace.trc, the file path where the trace log will be saved. Once configured, the trace captures detailed performance data, helping you identify and optimize slow queries. Now that you have explored how to monitor performance, the next step is to analyze workloads to identify queries with the biggest impact on performance. Queries that run frequently or consume the most resources often require more monitoring and analysis. This enables developers to identify areas for optimization. Dynamic Management Views, or DMVs, in SQL Server provide real-time information about query performance to help identify resource-intensive queries. Dynamic Management Views are system views in relational database management systems that provide real-time insights into internal operations, performance, and health of the database system. They are suitable for monitoring, diagnosing, and troubleshooting issues related to performance, resource usage, and query execution. For example, we can create a query identifying the top 10 queries consuming the most CPU time, allowing you to prioritize optimization for high-impact queries. You can access performance statistics for cached query plans using the sys.dm_exec_query_stats dynamic management view in SQL Server. The query groups results by query hash, a unique identifier for logically equivalent queries, and calculates the total CPU time consumed by each query using the sum total worker time function. For example, a query running 100 times per minute and consuming 70% of CPU is a good candidate for optimization. The next step you want to implement is dynamically adjusting indexes, which involves continuously monitoring database performance and modifying indexes based on evolving query patterns. This process improves data retrieval by enabling the database to locate information more efficiently as workloads and data structures change over time. For example, this command creates an index on the order date column in the orders table, significantly improving data retrieval efficiency. By adding an index, the database can quickly locate rows based on the order date column values rather than scanning the entire table. This optimization is particularly effective for queries filtering or sorting data by order date. For instance, adding an index like this might reduce a report's execution time from 10 seconds to 2 seconds. making it much faster and more responsive under heavy workloads. Finally, setting up alerts ensures you're proactively informed when performance issues arise, allowing you to respond to slow-running queries before they affect users. In SQL Server, alerts can be configured using the sp_add_alert store procedure, which is a built-in script for defining alert parameters. These parameters include the alert name, activation status, and a notification message for the database administrator. Specific conditions, such as performance thresholds, must be configured separately, typically using SQL Server agent alerts. For example, in this query, an alert named Slow Query Alert is created. This process defines an alert framework that can be linked to specific conditions or performance thresholds. The alert is activated and set to notify administrators with the message Slow Running Query Detected. Although the query doesn't specify a trigger condition, it provides the groundwork for monitoring performance. To link the alert created with sp_add_alert to a condition in SQL Server Management Studio, or SSMS, go to SQL Server Agent, select Alerts, and choose New Alert. In the New Alert dialog, set the alert type to SQL Server Performance Condition Alert. Then choose the performance object, for example, SQL Server :SQL Statistics, and the corresponding counter, for example, batch requests per second, that reflect the metric to monitor. After defining the condition, save the alert to complete the configuration. SQL Server Agent will then monitor and trigger the alert when the condition is met. In this video, you learned how to monitor and optimize queries over time. Database optimization is not a one-time task, but a continuous process. By monitoring and refining your queries over time, you ensure your systems remain responsive, scalable, and ready for the demands of the future. Optimizing database queries is like unlocking your application's true potential. As you've discovered, efficient queries, smart indexing strategies, and refined optimization techniques are the keys to maximizing performance and scalability. We began by exploring the core principles of query optimization, highlighting how well-structured queries enhance database performance and optimize resource utilization. Next, we examined various indexing strategies, focusing on techniques to organize data efficiently and significantly speed up query execution. Then, we applied practical indexing techniques, showcasing how to implement them more effectively to improve query speed and minimize processing time. After that, we reviewed complex SQL queries in detail, uncovering performance bottlenecks and applying targeted strategies to optimize their efficiency. Finally, we identified key best practices for query optimization and provided strategies for consistently designing and maintaining efficient, high-performing database queries. Mastering query optimization is essential for building efficient, scalable, high-performing databases. Applying these techniques can transform complex challenges into streamlined solutions, ensuring your applications run at their best. Welcome to Designing Scalable Applications. This module focuses on building systems that adapt seamlessly to growing demand. By mastering key principles, patterns, and techniques, you'll gain the expertise to design efficient, reliable, and ready-to-scale applications. We will begin by exploring the fundamental principles of scalability and understanding how they influence applications' ability to handle growth and demand effectively. Next, we'll examine key architectural patterns, learning to structure systems to support scalability while maintaining reliability and performance. Then, we'll focus on designing scalable application architectures, incorporating best practices to ensure adaptability and efficiency in real-world scenarios. After that, we'll implement load balancing solutions and discover how to distribute traffic evenly across resources to optimize performance and prevent system bottlenecks. And finally, we'll apply asynchronous processing techniques in .NET, enabling applications to handle tasks more efficiently and improve responsiveness under heavy loads. By the end of this module, you'll have the tools to design and implement scalable, high-performing applications that can easily handle growth. Let's unlock the potential for creating robust, efficient systems. Scalability is the secret behind the success of modern applications that handle millions of users every day. Understanding its principles prepares you to design systems that can expand effortlessly while staying reliable under pressure. In this video, we'll identify the key principles of scalability and how they support application growth. To begin, let's explore some scalability principles, starting with horizontal scaling. Horizontal scaling involves adding more servers or nodes to distribute a workload evenly across the system. Think of a store during a holiday rush. It opens more checkout lanes to keep lines short, allowing customers to move through faster. Similarly, horizontal scaling distributes users' traffic across multiple servers to ensure smooth operation. While horizontal scaling spreads loads across servers, vertical scaling increases the power of a single server. Vertical scaling upgrades a server's resources, such as increasing its CPU, RAM, or storage capacity to handle more intensive workloads. Imagine upgrading a car engine so it can carry more passengers or drive faster. Vertical scaling strengthens a server in the same way, enabling it to process more requests or store more data. Both horizontal and vertical scaling often require manual changes. However, elasticity takes a dynamic approach, adjusting resources in real time. Elasticity automatically scales resources up or down based on current demand, ensuring efficient resource use and cost management. Think of a heating system that senses the temperature and adjusts its output, warming up when it's cold and scaling back when it's warm. Elasticity adapts servers to changing workloads in a similar way. While elasticity manages resources efficiently, availability ensures that the application remains accessible regardless of load. Availability is the ability of a system to remain operational and accessible to authorized users at all times, even during peak demand. Consider an online streaming platform. You expect it to work whether you're watching a movie during peak hours or early in the morning. Similarly, availability ensures your application is always up and running, meeting user expectations regardless of traffic. Next, fault tolerance ensures your system can continue operating smoothly even when things go wrong. Fault tolerance is the ability of a system to keep functioning despite hardware or software failures. Fault tolerance in an application is like a spider's web. If one strand breaks, the web still holds together, ensuring the spider can continue its work. Similarly, fault-tolerant systems are designed to handle failures gracefully so that the application continues to run smoothly even when a component fails. Now that we've explored scalability principles, let's explore how they work together. Imagine a busy e-commerce platform preparing for a holiday sale. Horizontal scaling adds servers to handle a surge in customer traffic. Vertical scaling upgrades the database to accommodate more transactions and inventory. Elasticity dynamically adjusts server capacity during flash sales, reducing costs during quieter times. Availability ensures customers can shop without any interruptions day or night. And finally, fault tolerance keeps the platform running smoothly even if a server goes down or offline during the rush. Together, these principles create a system that grows effortlessly while maintaining reliability. In this video, you learned about the key principles of scalability and how they support application growth. These principles aren't just about keeping an application running, they're about delivering smooth, seamless experiences no matter how big the demand. Scalability and performance are two interconnected forces shaping a system's efficiency and adaptability. Striking the right balance allows systems to expand without compromising responsiveness, but achieving this requires careful planning and consideration of the trade-offs involved. In this video, we'll describe the relationship between scalability and performance. To get started, let's define scalability and performance and explore how they interact in designing reliable systems. Scalability is a system's capacity to handle increased workload as demand grows, often by adding resources like servers, increasing internet bandwidth, or expanding cloud storage. For example, a messaging app can scale by adding more servers to support a growing user base, ensuring smooth communication even during peak usage. While scalability focuses on growth, performance ensures the system remains efficient and responsive under its current workload. Performance refers to how quickly and effectively a system completes tasks directly impacting the user experience. Think about a food delivery app that processes orders instantly. This efficiency keeps users satisfied and engaged. Balancing scalability and performance is essential, but often involves trade-offs. For instance, adding resources to support growth can increase costs, while prioritizing performance might limit scalability without strategic planning. For example, consider an online store hosting a big sale. Scalability ensures the system can handle thousands of shoppers simultaneously by dynamically adding servers or infrastructure. And performance ensures that every shopper's page loads quickly and that their checkout process is smooth. Balancing the two ensures the store can scale efficiently without overspending on resources while keeping customers satisfied. In this video, you learned about the relationship between scalability and performance. Scalability ensures systems can grow with demand, while performance keeps them fast and reliable. Together, they enable developers to build systems that can adapt to any challenge, now and in the future. Scaling efficiently requires systems that adapt to growing demands. Microservices achieve this by breaking large applications into smaller, independent services, each capable of evolving and expanding independently. This modular approach ensures flexibility, resilience, and optimal performance when challenged with increasing workloads. In this video, we'll describe how microservices support scalability. To understand how microservices enable scalability, let's start by defining the core idea behind this architectural approach: microservices. Microservices are a software design approach where an application is built as a collection of small, independent services, unlike monolithic systems where all features are tightly interconnected. Microservices separate an application into distinct components. This modularity simplifies scaling by allowing services to grow independently based on specific needs. Now that we have examined what microservices are, let's explore the components of their architecture. A key advantage of microservices is how they enable scalability through independent services. Independent services focus on a single function, and they can be scaled independently without affecting other parts of the application. For example, imagine a video streaming platform during a major movie premiere. As more users stream the video, the platform can scale only the playback service to manage the load. This targeted scaling ensures the system remains efficient and responsive under pressure. However, independent services need a way to interact seamlessly, and that's where APIs come into play. APIs act as a lightweight connection, enabling the services to communicate between themselves while staying autonomous. For example, in an online store, a payment service API can interact with an inventory service API to confirm product availability before completing a purchase. By using APIs, these services can exchange information efficiently while preserving their independence, ensuring smooth communication across different parts of the system, even as they scale. With communication managed, microservices can also benefit from having separate databases for each service. A database per service prevents bottlenecks and improves data access efficiency by isolating workloads. Take a messaging app as an example. User profiles might be stored in one database, while chat histories reside in another. If the chat database experiences heavy traffic, it won't slow down access to user profiles. This separation ensures smooth performance and avoids resource contention. Finally, let's explore how microservices maintain reliability through fault isolation. With fault isolation, failures in one service don't affect the others, allowing the system to continue functioning smoothly. On an e-commerce site, for example, if the search feature encounters issues due to high demand, users can still browse products or complete their purchases. This design minimizes disruptions and ensures the application remains usable even during partial failures. Now that we've explored the key components of microservice architectures, let's combine them in a real-world system example. Imagine a ride-sharing app that can scale its route matching services independently to handle increased demand during peak hours without impacting the driver notification system. APIs provide seamless communication, like connecting the price engine to the route planner. Separate databases ensure that issues with the ride history storage won't slow down real-time trip tracking, and fault isolation keeps essential features like booking functional even if the review system experiences downtimes. These features collectively allow systems to grow efficiently while maintaining reliability under pressure. In this video, you learn how microservices support scalability by breaking applications into independent focused services. Microservices unlock the ability to scale specific components without overhauling the entire system. This modularity design boosts efficiency and ensures reliability even under intense demand.
Using message queuing with your application can greatly improve performance and help your app respond a little bit better to users. In this video, we're going to demonstrate the event-driven architecture for scalability. We're going to use RabbitMQ, which is a message queuing service, to demonstrate how these messages work. And I've got RabbitMQ running in the background on this Windows machine. So if we go to services, you can see RabbitMQ is running, and it's listening and waiting for messages that we can send and receive. So we have a very simple JavaScript application with two main files here, a producer.js, which I have open on screen. This service uses the AMQP library, which is a library that we can use with RabbitMQ to send and receive messages. I installed that ahead of time, and we'll use this library to use Node to send the messages and receive messages. In this JavaScript application, we're setting up a connection using AMQP. We create a channel on that connection, and then we set up a queue so that we can send the messages back and forth. Here I have a hard-coded message that says, hello, this is an event message. And then we assert that message to the queue and send it after it's been added to the queue and log to the console that the message has been sent. And once the message is sent, then the application closes and doesn't do anything else. We also have a consumer side that's able to, again, use AMQP to receive messages. I set up a connection to AMQP, create a channel on that connection, and then a variable called queue, which is just the event queue that we're going to receive the messages on. Then we log to the console that we're waiting for messages, and as messages come in, those messages will be displayed to the console. When this is running in the background, this will just continue to wait for messages as they go through RabbitMQ, and as they come in, they will be received in this application. So you can imagine a real-world scenario where you're using RabbitMQ. There's multiple clients that are listening for messages, a chat application, for example, and as those messages come into RabbitMQ, they will be received in the consumer side. So with RabbitMQ running in the background, on the consumer side, we're going to set that up to start listening for messages. So I'll do that first, and I'm just going to run this through Node, and that AMQP library will allow us to use Node to connect to RabbitMQ. The message says it's waiting for messages from RabbitMQ, and then we'll go on our producer side, and I'm going to switch to the other terminal, and I'm going to run this producer.js again using Node. So we're just going to run the Node application. What this should do is send that message to the queue. Hello, this is an event message. We'll see it repeated here on the producer side, and then it should also show up on our consumer window as it has gone through RabbitMQ. So it tells us that the message has been sent and what that message is. And when we switch to the consumer terminal, you can see that it received that message. Hello, this is an event message. Now we'll just change this slightly just to show how this works. This is another event message. We'll run this application again through Node. It tells us that it sent it. Send it to RabbitMQ, the server that's running on this machine. And then when we go back to the consumer side, you can see that's been received. By using a message queue like this, we can make our application a lot more efficient because the message queue service handles all of that sending and receiving. We don't have to manually code all that for an application like this. So that's how you can use messaging in your application to make it more efficient and more robust.
Imagine building a system that doesn't just grow with user demand, but does so effortlessly, maintaining speed and reliability no matter how many people use it. Utilizing stateless design and load balancing are key to making this happen. In this video, we'll explain how stateless design and load balancing enhance scalability. To begin, Let's explore the elements of stateless service and load balancing, starting with stateless services. Stateless services process each request independently without storing any data about previous interactions. This independence simplifies scaling because servers don't need to share session information or coordinate with one another. For example, consider a vending machine. Every time you interact with one, you start fresh. You insert your money, make your selection, and receive your item. The machine doesn't remember what you bought last time or who you are. It only processes the current request based on the inputs you provide at that moment. And adding more vending machines allows the system to effortlessly handle more users. Similarly, stateless services let systems scale smoothly as demand grows, while stateless services make scaling easier. Managing increasing user requests requires spreading traffic across multiple servers to prevent bottlenecks, which is where load balancing becomes essential. Load balancing distributes incoming requests among multiple servers, ensuring no single server is overwhelmed. It's like a restaurant host who directs customers to available tables, maintaining an even workload for the staff and providing a better dining experience. By balancing traffic, the system ensures all servers handle requests efficiently, enhancing both reliability and speed. Even with load balancing, it's crucial to ensure the servers themselves are functional and ready to process requests, and health checks play a critical role in maintaining system reliability. Health checks regularly monitor servers to verify they're working properly. If a server fails, the load balancer redirects traffic to healthy servers, ensuring uninterrupted service. For example, consider inspecting buses before they start their routes. If one isn't roadworthy, another bus will take its place to keep the schedule on track. Health checks work the same way to ensure functional servers handle user requests. Now that we've explored these concepts, let's combine them to explore how they enhance scalability and reliability. Imagine an online store experiencing a surge in traffic during the holiday rush. Stateless services allowed them to add more servers seamlessly, handling the increased load without disrupting requests. Load balancing spreads traffic evenly across all their servers, preventing any single one from becoming overwhelmed. Meanwhile, health checks redirected traffic from malfunctioning servers to healthy ones, ensuring the site remains fast and reliable. Together, these principles delivered a smooth shopping experience for customers. In this video, you learned how stateless design and load balancing enhances scalability. By leveraging stateless services, load balancing, and health checks, you create a foundation for scalable, resilient systems that deliver seamless user experiences.
When you're building a web application, making sure that your application is responsive and isn't subject to slowdowns, particularly when you get a lot of traffic and a lot of people using the website, is very important. You can use caching and asynchronous processing to improve your website to make it more responsive. So in this screencast, we're going to demonstrate how to integrate caching and asynchronous processing to improve scalability. I have a simple ASP.NET web page here that I've put together. We're just going to really work out of this program.cs file for this screencast. I'm using a Redis server to do the caching. A Redis server is an open source server that will actually manage caching for your website. And I'm using a library here, the Caching Stack Exchange Redis library. In my builder object, starting on line 5, I'm adding the Stack Exchange Redis cache with some options. I'm going to communicate to the cache on localhost port number 6379, and I'm just giving it an instance name so I can differentiate it from other instances if I needed multiple instances of the cache. So I'm calling this sample instance. I also have a background task service that I'm using, and that's an object that I've created here, and I'm just using that to manage the communication with the cache. Then I have a route, a cache route, starting on line 15. When we hit this route, it's going to pass in the distributed cache object with the variable name of cache. And inside the method, I'm setting a cache key, which identifies this instance of the data object that I'm creating called sample key. The first thing I want to do is try to set the data object that we're going to use. And imagine a real world scenario. We would get data from the cache and put data to the cache as we need it. So I'm going to first try to fill the data object that I'm instantiating here
from the cache itself. So I have this line on line 19, var data equals await, and then cache get string async, and I'm passing in the cache key. So that's going to go to Redis and see if any data exists for that cache key. If it does, I'm going to fill that data variable with the data from the cache. The next line says if the data is null, if there's nothing in the cache, then I'm going to populate that data variable with just a simple string in this case, hello from Redis cache. I'm going to set the string async using the cache key, and then I'm just going to talk to the Redis cache and set that cache key sample key with that data item. I'm also setting an expiration, and I'm just giving it 5 minutes. So what this means is that after 5 minutes, Redis will automatically delete the data from the cache. And that's how a cache works. So you can actually refresh this more infrequently if you have data that doesn't change very much, or more frequently if it changes a lot. But the cache will hold that data so that it doesn't have to read from a database or go out to an external API. It'll hold that data in its memory and then continue to pull from that cache as you need it without having to do calculations or lookups or anything else. And so you would set that time span based on how long you would like the items in the cache. Frequently updated data should be shorter. Data that doesn't update very frequently can be much longer. And then it's going to return the results okay with the data in there. So again, if the data doesn't exist in the cache, I populate it with my own logic here. If it does, then I just return the data from the cache. Now I'm going to start the Redis server. I don't have that running yet, so I'll get into my command line. You'll notice that I'm in the Linux command line here in Windows. This is the Linux subsystem that I'm in, and I installed Redis on this Linux subsystem. You don't need to do that. You can run Redis right from Windows, but I'm running it from a Linux subsystem just to illustrate that can be done. So I'm going to go ahead and run the Redis server with a monitor so we can see what's happening and watch it in real time as we communicate with it. So it just tells me it's ready to go and it's monitoring in the background. And now I can go back to my application. So I'm going to use .NET Run to run that. Our application is now running, and I can go to localhost 5217 to interact with the Redis cache. Now I'm going to have to go to our route, which is cache. We've populated that data string hello from Redis cache. Now if we go back to the monitor, the Redis cache has had some interactions. That's because we posted information to the Redis cache. The data is hello from Redis cache. The data on the web page was actually the data that I had populated in the code in this logic starting at line 22 because the cache was empty. Now if I go back to the web page and refresh, this hello from Redis cache is actually from the cache. It actually pulled that data from the cache. If we go back to the monitor, it got that data from the cache. And each time I refresh it, that line repeats. I refreshed it again. We go back to the monitor. It's pulling from that cache. So the cache holds the data for 5 minutes. After 5 minutes, that data will be deleted. And then if I refresh the page again, it would actually pull it from this logic. It would populate the data using this string, write it to the cache, and then we get another 5 minutes of the data in that cache. So using a cache like Redis cache is a great way to improve performance of your website, particularly when you're getting a lot of traffic or making a lot of API calls, doing a lot of calculations or database reads. A cache can really improve the performance of your website by saving time to do that work and then improve the performance for your users.
Imagine an online store hosting a flash sale with thousands of users flooding the website simultaneously. Despite the surge in traffic, the site remains responsive, fast, and reliable. No crashes, no delays. How does the system handle these demands? The key is load balancing. By spreading traffic across multiple servers, it prevents overload and ensures systems stay responsive and reliable. In this video, we'll identify the role and purpose of load balancing in scalable systems. Let's begin by exploring load balancing concepts, starting with what a load balancer is. A load balancer is a system that distributes incoming traffic across multiple servers, preventing any single server from being overwhelmed. Imagine you're at a grocery store with multiple checkout lanes. The store manager directs you to the shortest line to keep things moving quickly. That's how a load balancer works, redirecting requests to the least busy server to prevent delays or crashes. Load balancing uses rules called algorithms to distribute traffic efficiently, and one commonly used algorithm is the round-robin algorithm. The round-robin algorithm is a method that cycles through available servers to distribute requests evenly. Because of this, it helps to prevent bottlenecks, maximizing resource utilization, and therefore maintain consistent performance across the system, making it an effective strategy for balancing workloads in scalable applications. To further illustrate, let's imagine a teacher handing out assignments to students one at a time, moving down each row of students until each one has an assignment. A round-robin algorithm distributes requests in a similar way, ensuring each server gets its share of the workload. Another load balancing concept is the use of health checks. Health checks ensure to make sure servers maintain reliable performance. Health checks are regular tests to ensure servers are functional and able to handle traffic. If a server fails during a health check, traffic is redirected to the other servers. Think about a chef confirming their kitchen staff is ready before service begins. If someone isn't prepared, the chef relocates the tasks to the others. Health checks work similarly by testing servers regularly and redirecting traffic if one becomes unavailable. Load balancing can also ensure a consistent user experience by keeping users connected to the same server throughout their visit, a process known as sticky sessions. Sticky sessions ensure that a user stays connected to the same server throughout their session. Sticky sessions help maintain context and continuity, like preserving shopping cart items or user preferences without requiring the server to repeatedly retrieve data from a shared database or cache. They are especially useful when stateful interactions or personalized experiences are critical to user satisfaction. For example, imagine dining at a restaurant and throughout your meal, the same waiter takes care of your table. This person remembers your drink, orders, and preferences during your visit, ensuring a smooth and consistent experience. Sticky sessions work the same way. They keep a user connected to the same backend during their session, ensuring their shopping cart or preferences remain intact without needing repeated data retrieval. Now let's explore how these concepts work together in a real-world scenario. Imagine an e-commerce website experiencing a huge traffic spike during a product launch. The load balancer comes into action using a round-robin algorithm to distribute the request evenly across multiple servers, ensuring no single server is overwhelmed. At the same time, health checks monitor the server to ensure that they're functional. If a server goes down, the load balancer quickly redirects traffic to a healthy server. Sticky sessions keep customers connected to the same server throughout their entire checkout process, preserving their shopping carts and ensuring a seamless experience. Together, these strategies ensure the website remains fast and reliable during peak traffic. In this video, you learned about the role and purpose of load balancing in scalable systems. By understanding and implementing these load balancing concepts, you'll be able to work to prevent delays and crashes, even in high traffic systems.
When you're developing a backend where you expect a lot of users to be getting data or interacting with that backend, it's important to create an environment where you can balance the load on any one server by spreading out that load, the amount of traffic going to multiple servers. Load balancing is important because it helps you distribute how much traffic each server will get. There's software that can help you with load balancing. We're going to use an open source software package called Nginx. It's spelled Nginx, and Nginx is developed to help automatically balance the load between multiple servers or multiple applications that are running. And so we're going to demonstrate how to configure load balancing using Nginx in this screencast. I have a couple of simple node servers here set up. I have two files, server1.js and server2.js. And we're going to use these servers to replicate servers that would be running applications using a node server. So you can distribute the load between multiple node servers either on completely separate machines or on individual machine. And this Nginx, this software, will help distribute how much traffic is going to each so it doesn't overload one single server. These are very simple applications, these JavaScript applications, just listening on different ports. So for server 1, listening on port 5001, and server 2 is listening on port 5002. The software is just creating a server and returning a single line, hello from backend 1 and hello from backend 2, so we can see that we're interacting with different backends. When the server starts up, it just says the backend is running on this specific port, so we can see that it's actually working. I have these two servers set up, and I have Nginx running in the background. I have the upstream backend server's parameters set to localhost, which is 127.0.0.1, with the port numbers 5001 and 5002. I'm telling Nginx that I have two servers that I want you to be aware of, and they're available on these ports. So this is where if you have multiple machines, you can have a single machine that runs Nginx, and you can tell it which IP addresses and ports to listen on. And then we have our server listening on port 80, and the server name is localhost. So that just helps us know how to set up NGIX and what NGIX is going to be doing for us. Now, in order to get this working, I'm going to have to run both servers. So I'm going to start with server 1, and I'm going to just use node to start that application by using the command node server1.js. Backend 1 is running on port 5001, which is what we have here, backend 1 running on our port number. So it's just telling us that it's up and running. Now we'll do the same for server 2. I have another PowerShell instance running here. We'll do the same thing here. And we're going to say node server2.js so that we have backend 2 running on port 5002. So now we've got both of our servers running. And what we want to do is every time we communicate with localhost, it doesn't have a port number, it's just a single IP address or single location, localhost. Nginx should distribute that between the two servers, the calls that we're making between the two servers. So I'm going to get into my terminal here, and I'm going to run curl command. And curl just sends a request to the specific address that I indicate. So here we're going to go to localhost, and localhost again doesn't have a specific port number because we're not trying to hit an individual server. We're trying to hit the general localhost port essentially, which is what we indicated in here. It's 80 and localhost. This is what we're going to be communicating with Nginx on. So we're just going to make a call to localhost, and Nginx should distribute the load between the two servers. So when I run this, it communicated through localhost and hit one of the servers, and it says hello from backend 1. And we got a 200, which means it communicated fine. So we did get our message, and all this information is just coming from that request that we made to our server. Now let's run it again. So now Nginx distributed the load, and we went to the second server, hello from backend 2. So both servers are being communicated with because it's going through Nginx and distributing that load. If I run it again, we should get backend 1. So now it's just continuing to distribute how the load gets managed through Nginx by hitting each server independently each time we make a request. So you can manage if you're getting hundreds of thousands of requests a day or even an hour or a minute. A service like this, if you have more servers running that has all the same information and the same content, you can distribute that load between servers so one server doesn't get bogged down and its resources used up too quickly by distributing the load across multiple servers. This can make your experience for your users much more efficient and much speedier and more pleasant to interact with. I'm going to go back to my configuration here, and you'll notice that we can also indicate how we manage server health. So we can have a health parameter here. It will manage where traffic goes when servers are not healthy or something has gone wrong. So to illustrate this, I'm going to shut down server 2. So server 2 is no longer running. So if Nginx detects that server is no longer available, it will automatically distribute the traffic to the only active server. So if I run my curl command again, it takes a second, but it realized that server 2 is not available. So every time I run my curl command, it will always go to backend 1 because server 2 is no longer there. And you can imagine, again, in a situation where there's a number of servers, some servers may fail, some servers may need to be rebooted. Using a system like this, distributing load using Nginx or a similar service, you will always make sure that your users get sites that are available because it's going to servers that are actually online and ready to serve traffic rather than trying to hit a server that is down. So load balancing is very important, particularly as you get more users and more traffic to your website. You want to make sure that you can handle that traffic and those users by using something like load balancing. When you're working with multiple servers and you want to make sure that your users always are served the pages that you need, using a load balancing service can be super helpful. In this lab, we're going to implement load balancing in a simulated environment using Nginx or AWS Elastic Load Balancing. In this particular context, we're going to use the open source service Nginx. In step 1, we're going to configure Nginx as a load balancer. I have two backend servers represented by backend 1 and backend 2. These are just two servers that are going to run locally. You can obviously have your servers on different physical machines distributed across a network, or multiple individual servers running on a single machine. These are going to run on separate ports. This one's running on 5002, backend 2, backend 1 is running on 5001. We're going to use Nginx, which is a service running in the background. It's a command line service. We're going to use Nginx to load balance between the two. So as requests are made to localhost, Nginx will distribute the load between the two servers. Obviously, we can add many more if we wanted, and we could see how that would operate in that context. The first thing we want to do is modify the Nginx configuration file in step 1. So I've got the configuration file here. This is on Windows. I installed it to C Nginx, and then there's a config folder, and we got into the config folder and opened up nginx.config. There's a lot going on in this file that you can ignore. Leave the defaults as they are. I added the upstream backend servers, which is telling Nginx where to look for the servers to distribute the load. Remember that I had the servers running on 5001 and 5002. We saw in the programs here. So whatever your port number is for the servers, that's what we're going to add here. Now, in some cases, you may not have a port number. You may just have a regular URL that's a server that's running on your network. So you can just put in the URL. But what you want to put here is the specific IP address and, if necessary, port numbers for the servers that you want to distribute the loads to. So in this case, it's going to be 5001 and 5002. We also added this server section. It's going to listen on port 80 with the name localhost. This is actually commented out, so we're really just focusing on the port there. And we're going to proxy pass to backend servers, which we've defined up here. So that means when I try to hit localhost, it's going to pass the load onto one or more of those servers based on where things are. So we'll demonstrate this by starting up both the servers. I have two PowerShell terminals open. I'm going to start this server. So backend 2 is running. Now I'll go to this terminal and run backend 1. So now both backend 1 and backend 2 are running, 5001 and 5002. And now we can use Nginx to load balance between the two. So when I go to localhost, I'm going to get my message that I'm hitting one or the other server in the two that I have. So here it hit backend 1. So when it hit localhost, we told Nginx to send it to one of these servers using this proxy pass item, and it's going to send it to one of the servers. In this case, it sent it to backend 1. Now, if I refresh the page, it's going to load balance and send it to backend 2. It's just going to go back and forth so that both servers get equal load, and it doesn't overload any individual server. Now, with Nginx, I can actually stop one of the servers, and it says the application is shut down. And now when I go back to the browser, we'll take a second while it resolves the name, and it knows that the second server is no longer available, so we'll just hit backend 1. So you can imagine a scenario where you have a dozen servers and you need to do maintenance on one of them. You can take one of those servers down, and Nginx will continue to load balance between the remaining 11 servers. Now in step 2, we're going to enable health checks in Nginx. So I'm going to restart this server. And then I'm going to go back into my config file. And here I want to put a timeout just in case things go wrong. For each server, I'm going to say you get to fail 3 times. And you get to wait 10 seconds before that failure happens. So max fail is 3, timeout is 10 seconds. And so now when Nginx attempts to hit these servers, if it fails more than 3 times, then it will automatically go to a different server. Or if the server doesn't respond within 10 seconds, it'll load balance. So this gives your users a much more responsive environment in which to work. So I'm going to go ahead and save that file. And the last thing I need to do is restart Nginx. So I'm going to use this command in PowerShell, nginx.exe-s reload. And I'll run that. You can just see it returns to let me know that it reloaded. And now we can go back and try this again. Now, it's going to be difficult to illustrate the timeout because these servers are very responsive, but in a real-world environment, if either of these servers failed to respond within a certain amount of time, it would load balance and go to the other server. And that is true for how many servers you have. So this is a very simple way to use a tool like Nginx to load balance between multiple servers so that your users always have a responsive and available website.
Ever wonder how some applications will run multiple tasks simultaneously without slowing down? This requires the ability to manage operations independently, ensuring a smooth, uninterrupted experience. We call this asynchronous processing. In this video, we'll describe the key components and benefits of asynchronous processing. To begin, let's explore the concepts of asynchronous processing, starting with asynchronous tasks. Asynchronous tasks run independently from the main programmer thread, improving responsiveness by preventing the system from getting stuck on time-consuming operations. In simple terms, they are tasks that can be executed in the background while the rest of the program continues running, preventing delays or interruptions. For example, when you log into a web application like an email service, the app fetches your emails in the background while you navigate the dashboard. This ensures smooth interaction without delays caused by ongoing background operations. While asynchronous tasks improve responsiveness, managing multiple operations effectively requires a mechanism to organize them, which is where we make use of queues. Queues provide temporary storage to manage background tasks systematically, ensuring they are processed in an orderly manner. Imagine using a ride-sharing app. When you request a ride, the system places your request in a queue until a driver is available. This ensures tasks are handled efficiently, balancing demand without overwhelming the system. With tasks organized in queues, concurrency enables multiple operations to run simultaneously, boosting efficiency and speed. Concurrency allows systems to execute multiple tasks simultaneously, making better use of resources and improving performance. For instance, streaming services use concurrency to preload upcoming scenes while playing the current one. This simultaneous processing ensures a seamless streaming experience even with large-scale user activity. While concurrency improves task execution, non-blocking I/O, which stands for input-output, ensures systems can handle input and output operations efficiently. Non-blocking I/O allows asynchronous input and output operations to run without interrupting other processes, maintaining system responsiveness. For example, when you upload a file, non-blocking I/O lets the system handle other tasks while the upload completes in the background. This keeps the interface responsive, letting you perform other actions without interruptions. In this video, you learned some of the key components and benefits of asynchronous processing. By leveraging asynchronous tasks, queues, concurrency, and non-blocking I/O, systems can deliver seamless experiences even under heavy usage conditions.
When you're processing large amounts of data, or you're dealing with situations where you may have to work on a lot of tasks but exit out of a task if something goes wrong or if a certain condition is met, using queues can help you do that more efficiently. In this screencast, we're going to look at how to use queues and how we can make our programs more efficient by using them. So we're going to demonstrate how to configure queues for asynchronous tasks in a .NET application. Queues can be especially important in asynchronous applications because processes are running asynchronously. Things can go wrong or get out of order, and it may be important to queue them up so that you can manage them in a more efficient way. I have on screen a simple console application and this main method, which will run when the program runs. The first thing I'm doing is creating a variable with a list of queued items. I'm using the built-in queue library that .NET provides. I'm setting up a variable called queue,
And then I'm going to use the enqueue method to enqueue 3 tasks. I'm adding these tasks to the queue variable that we can then process later. So you can imagine these are very specific activities or processes that you'll need to run. I'm just using task 1, task 2, and task 3 as an example here, but you can use that enqueue method to queue up as many tasks as you want. Think of it as adding these tasks to a bucket, and then they get processed in the order in which they were added to that bucket or a list or whatever metaphor you want to use so that you can process them. We're also going to create a cancellation token, which we can use to stop a task if something goes wrong or if a certain condition is met. Then we're going to create a worker. Now you'll notice that the worker variable is being set to a background worker, which I've created a class for here. And all this background worker does is it takes in the queue that we're passing in, the queue that we just created, and the cancellation token. And then it has a start processing method. And here it's going to check and see if the queue count is greater than 0. We don't want to operate on a queue that doesn't have any items in it. And it's also going to check if the cancellation token has been passed in. If we've requested a cancellation token, it's going to exit out of the worker. It's going to stop that process. So that gives us the ability to exit under specific conditions. We're creating a variable task where we're going to dequeue the items in the order in which they were added to the queue. All dequeuing does is it removes it from the list and then pulls it out so that we can work with it. So when we dequeue, we're adding it to that task variable, and then we can do something with it. In this case, we're just writing to the console using a small delay to simulate processing whatever's in that queue and then writing out to the console that the task has been completed. So let's go back to program.cs. This is what our background worker does. So now that we've created our background worker that will process these queued items, we call the start processing method that we just saw in the background worker object, and we're going to process this as an asynchronous method. This will run in the background, but the main thread will still be responsive as it's processing that queue. As it's working through each item in the queue, because it's asynchronous, we can interact with the UI. We're going to actually have an opportunity here to input a line or a word exit. If we type in exit into the terminal, we're going to send that cancellation token. We're going to set the cancellation token to cancel using that cancel method, and we're going to write out to the console what we typed in. And we'll use the await keyword to run the worker task, and then when the program's done, it'll say program has exited. This is how we can use a queue with async in order to process a number of tasks. So I'm going to run this, let it compile. And then you can see that it's running task 1. It tells us that it's completed, processes task 2, tells us it's completed, and the same with task 3. So in this instance, it just went through the list of tasks that we added to the queue and then processed them asynchronously in order. Now I'm going to run it again, and this time I'm going to type in exit. The cancellation token was triggered. It stopped the worker we saw in our background worker process, and the program exited it. Because it's async, we're able to interact with the user interface while that queue is running. So you can imagine a number of scenarios where that would be useful. If you have a task, the user wants to cancel the task, you can have them press a button or type in a word, and the queue would stop processing the items rather than being stuck in a situation where they can't exit. You can also imagine situations where an error occurs in processing the queue and you don't want to process anything after the item that caused the error. So queuing can really improve the performance of apps, make sure that data doesn't get corrupted, and make the user experience a lot better. In this lab, we're going to implement asynchronous tasks using queues and background jobs in a .NET application. I've got a simple .NET application set up here, and we're going to start with step 1 where we're going to set up the task queue. So I have a task.queue.cs file, and I have my public class task queue that we're going to use to create methods that we can interact with elsewhere in the app. The first thing we're doing is we're establishing that _queue variable, which is a private variable for this class. And then we have our public task queue method. And in this method, we're going to assign queue to this channel.createUnbounded. And this just establishes that queue variable as a queue item. It's an unbounded queue, which means we can continue to add items to it. And this method call enables us to do that. In the second method, enqueueTasks, this is where we actually write items to the queue. So we're going to use the await keyword with _queue.writer.write async, and that just adds items to the queue itself. We're passing in a task there for this application. And then finally, we have a read method. This is the dequeueTask method, and this is where we're going to pull items out of the queue. So we're returning a value, and we use the await keyword again because it's an async task, and we're writing to the _queue variable using the .read async method. So this will allow us then to read from that queue. In step 2, we're creating a background worker. I have another class file with a class called background worker, and this will continually process tasks from the task queue. We also have a little bit of a time delay here just to illustrate how this works, but this will allow the application to make sure that the queue is continually being processed. So in the first part of this, we've got our background worker that we're setting up, and we're essentially instantiating the background worker by setting _task queue, which is a private variable, to whatever we pass in, which is going to be that task queue that we create in other parts of the application. And then we have our processing. This is, again, an async task. It will run in the background while other things are happening in the application. And while the task queue is full, so while task queue get reader wait to read async, it tells us that the task queue is still full, we're going to just pop items off of that task. So we're going to use getReader.wait to read async, which is an async function that will attempt to read from the variable _task queue, which we set up in that background worker public method. And then we'll dequeue, and then we'll execute the task essentially by using the await task method. In step 3, we're going to enqueue and process tasks. So now we'll go to our program. So we've got our 2 utility functions set up, and now we'll go to the program. And here we're just creating a task queue. In the first line, we instantiate our background worker, and then we're starting our task processing by calling worker.startProcessing, which was the method that we saw in that helper function. And then we go through each item in our task. Before I get to that, for the worker task, we are using the method worker.startProcessing. And if you remember in background worker, that was the method that we had created there. So we use worker.startProcessing to get that worker task going. We use a loop to go through each item in the queue. So here in our loop, we have an await statement where we're going to actually add items to the queue. So we give our task ID I based on the number in the loop. And then we enqueueTask, which is where we add our item to the queue itself. We add a little bit of a delay, and then we're writing out items to the console here. That enqueueTask, which is the method that we wrote in task queue, is being used in the context of adding items to the queue. Now in this case, the only job that this queue is performing is to write to the console with a small delay between the two.
Building scalable applications is the cornerstone of modern software development, ensuring systems thrive under growing demands. As you've discovered, mastering principles, architectural patterns, and techniques like load balancing and asynchronous processing is crucial for creating efficient, reliable applications. We began by examining the core principles of scalability and how they enable applications to manage increasing growth and demand efficiently. Next, we explored essential architectural patterns, focusing on designing systems that ensure scalability while preserving reliability and optimal performance. Then, we focused on creating scalable applications, architectures, applying best practices to achieve adaptability and efficiency in practical scenarios. Next, we explored load balancing techniques, focusing on strategies to evenly distribute traffic across resources, improving system efficiency and avoiding performance bottlenecks. And finally, we examined asynchronous processing techniques in .NET, showcasing how they streamline task management and enhance application responsiveness to handle heavy workloads effectively. Scalability is essential for developing applications that perform reliably under increased demands. By applying these principles and techniques, you can build systems that are not only efficient, but also adaptable to the challenges of modern software development. Welcome to using Microsoft Copilot for optimizing code and database performance. In this module, you'll learn how to harness the power of Microsoft Copilot to streamline application code, improve database query efficiency, and address performance bottlenecks. We'll begin by exploring how Microsoft Copilot enhances code optimization, highlighting its features for efficiently refining and improving application performance. Next, we will examine database query optimization, discovering how Copilot can analyze and suggest improvements to streamline database operations. Then, we will focus on optimizing application code using Copilot, applying its intelligent assistance to boost performance and maintainability. After that, we will explore debugging with Copilot, leveraging its suggestions to identify and resolve issues quickly, ensuring robust and error-free code. Finally, we'll combine it with a performance optimization project, applying Copilot's capabilities to real-world scenarios to solidify your skills in improving code and database performance. By the end of this module, you will be equipped with the skills to enhance system performance and deliver optimized, reliable applications. Imagine having a guide that helps refine your work, ensuring every piece of code is clean, optimized, and built to last. With Copilot, you can streamline development, elevate performance, and set a new standard for maintainable professional-grade software. In this video, we'll identify Copilot's AI-driven features that assist with code refactoring and performance improvements. To begin, let's explore some AI-driven features of Copilot, starting with refactoring suggestions. Refactoring suggestions aim at enhancing code organization and clarity without changing its functionality. While Copilot doesn't automatically perform refactoring, it can guide users through best practices, suggesting ways to simplify structures, reduce redundancy, and make the code more efficient and maintainable. For example, if your code contains repeated logic across different sections, such as a block of 10 lines that perform a specific calculation, Copilot might recommend consolidating it into a single reusable function. By replacing these repetitive blocks with a function that can be called in just one line, the code becomes more concise, easier to read, and simpler to maintain. This approach not only reduces duplication, but also minimizes the chance of errors when updates are needed, as changes would only need to be made in one place. This approach reduces duplication and simplifies future updates. Once your code is refactored for clarity, Copilot can help you improve its efficiency by offering general advice on performance enhancements. Performance enhancements are changes made to the code with the goal of speeding up execution. Copilot can provide tips on optimizing performance by suggesting better coding practices. Copilot doesn't directly identify specific bottlenecks in your code, but it can offer valuable advice on refining loops, algorithms, and operations to improve execution speed and resource usage. For instance, Copilot might propose adding an exit condition to a loop to reduce or eliminate unnecessary iterations. These kinds of improvements can lead to faster, more efficient systems. After optimizing your program's performance, Copilot can also guide you in writing flexible and maintainable code by writing code patterns. Code patterns are reusable solutions to common programming challenges. Copilot explains techniques like dependency injection, which decouples components by allowing tools and dependencies to be passed into a program rather than hard-coded. While Copilot doesn't implement these patterns for you, it provides valuable guidance to help you understand and apply them effectively. For example, Copilot might suggest improving your project's consistency by standardizing variable name conventions. This not only enhances readability, but also ensures your code is easier to maintain and collaborate on. In this video, you learn about AI-driven features that assist with code refactoring and performance improvements. By harnessing the power of AI tools like Copilot, you're not just improving your code, you're developing skills to write cleaner, faster, and more reliable software that meets professional standards.
One way to improve your app's performance is by detecting and improving inefficiencies in your code, making your code run better, faster, and more efficiently. In this screencast, we're going to demonstrate how Copilot identifies and highlights inefficient code. You can use AI tools like Copilot to examine your code and provide you with feedback to make your code more efficient.
I have a simple Node.js app, very simple. It's a single file, app.js. And I've got some example code here that we're going to work with Copilot on to improve the efficiency of how this app does its work. In this first example, I have a data array, a constant called data with an array of 5 numbers, and it just loops through those numbers and essentially sorts them out. I'm going to ask Copilot to improve the efficiency of this loop to see if there's ways that we can make it better. So I'm going to copy this code out of my application, and I'm going to open Copilot, and I'm going to ask it to improve the loop by pasting the entire loop into Copilot with a prompt. So simple prompt, and then I'll paste the code in below, and Copilot will examine this code and hopefully provide a more efficient way to work with this. So it does. It's examined my code, and it says I should use the filter and map array methods in JavaScript to make this more efficient. And it also tells me why. It's using a higher order function to achieve the same result in a more succinct and readable way. So you can see it's a lot more succinct, a lot easier to read, a lot easier to debug in the way that Copilot has provided it. So I can copy this code out and just paste it right into my app and improve that example. For the second example, I want to introduce a more complex problem. So in the second example, I'm using getData with an async method, and I'm querying a database here and passing in the ID and then returning the data from that. And then I'm assigning user 1 and user 2 to the results of the getData method. So what I'm doing here is multiple database queries. When I assign user 1, it calls the method with the ID passed in, and then I do the same thing for user 2. And you can imagine if you have a number of users, this can get very overloaded and get bogged down because we're making multiple database calls. So I'm going to copy this code out now, and I'll go back to Copilot, and I'm going to ask it to help me improve this code. So I'm asking it to help me refactor the code. Refactoring is just reworking the code to remove inefficiencies, to remove bugs, and to improve performance. So I'm going to ask it to give me some feedback on how I can do that with this code block. And again, I'll paste in all the code there and see what Copilot gives me back. And it does tell me that I can reduce repetition to improve performance by retrieving the data from multiple users in a single query, and it gives me the more efficient version. So here it's still using the getData method, but it's only calling getData once, and then it's using the find method on the user's object to assign user 1 and user 2. So it's essentially getting the data once, and you can imagine a scenario where the data is on a different server or has to make an API call, which can take time. So instead of having to make that call multiple times, it's just going to make it once, and then I'm going to use the find method to then make that assignment, which is more efficient. So I'm going to copy that out, and then I'll just paste that in as well. So now we have a more efficient operation for that database call, and that will definitely improve the performance of the app. Now I want to do one other thing. I want to use dependency injection to, again, continue to improve this database call. I've already got the code that Copilot showed me and provided for me, so I'm going to just prompt it again. Now that it has the context for what I want it to do, I'm going to go back to Copilot, and I'm going to give it a new prompt. And I don't have to repaste the code in because Copilot already has that code. So I'm just going to say, show me how to apply dependency injection to this code. And by this code, Copilot will know that I meant the code that it just provided to make it more maintainable. So I'm going to go ahead and prompt it with that query. It's actually taken that database code that it provided, and it's created a class called database service. And it's using this approach now to better improve the code and make it more performant overall. I've got a class that I can use, I can instantiate, and then I can call the getData method within that class. It's not super important for 2 users, but when you have hundreds or even thousands of users to do this with, you can improve your performance of your code by using an approach like this. So again, I can copy this out of Copilot and select my getData method because I don't need that anymore, and paste in the new code, and now I've got my class with the getData. This is also asynchronous, so Copilot's improved it by making it async. And then we have a connection object, which we would need to put in. We create a database service object by calling that database service class. And then we have our main method, which will run that
getData method within the database service object asynchronously so we can more efficiently improve our code. You'll notice that it kept the single call to the getData method. So it's still using that other improvement that it gave me, and it's using that find method on the user's object. So it didn't change that. It just changed the structure of how the database call is made, making it more efficient and improving the performance of how it works. So these are 3 examples of how you can use Copilot to improve your code, make it more efficient, make it more readable, and make your app more performant. You can have Copilot simply review your code and then you can make the changes yourself, or you can have it provide you with improvements that you would then go through and review and apply to your application.
Performance in SQL queries depends on how efficiently they retrieve and process data. Small inefficiencies in queries can accumulate, causing delays, wasting resources, and slowing down your database. With the right techniques, these bottlenecks can be identified and resolved to optimize query performance. In this video, we'll describe how SQL queries exhibit inefficiencies that can be optimized. To begin, let's explore how to fix common SQL query inefficiencies, starting with avoiding the retrieval of unnecessary data. Retrieving unnecessary data can waste resources and slow down your database. One common query that often retrieves unnecessary or unneeded data is select asterisk or select all, which retrieves all columns, even ones you might not need, adding unnecessary load. For example, this query retrieves all products from the products table using select asterisk. Instead, you can specify only the columns you need, like product name and price from products using select, like in this query. This approach reduces the amount of data processed and transferred, making your queries faster and more efficient. Now that we've explored how reducing unnecessary data can make your queries more efficient, let's examine the use of indexing for joins. Another impactful way to clear up inefficiencies. Recall that joins combine data from multiple tables, but can be slow without proper indexing. Without an index, the database must compare every row in one table to every row in the other table, a process known as a full table scan. This exhaustive comparison significantly increases execution times as the amount of data grows. Adding an index to the join column speeds up matching rows, improving performance and efficiency. For example, this query retrieves specific columns from products and orders tables. The products.product name column provides the product's name, while the orders.order_date specifies the date associated with the order. Then, the inner join operation combines the products and orders tables by matching rows based on the product ID column. If the product ID column is indexed in both tables, the database can quickly locate the matching rows, significantly improving the join's performance. This ensures that only the row with a corresponding product ID in both tables are included, effectively linking each product to its related order. Now, let's explore how adding filters can optimize your queries by limiting retrieved data. In SQL, the where clause is a powerful tool for adding filters to your queries, ensuring that only relevant rows are included in the results set. For example, in this query, a where clause filters the data by including only rows with an order date later than January 1st, 2023. This ensures that the database retrieves only recent orders, reducing the amount of data processed and improving performance. Now that we've explored how to add filters, let's examine how simplifying nested subqueries can improve efficiency. Nested subqueries often lead to multiple redundant scans of the same data. Subqueries slow down query performance. For example, this query retrieves all columns from the products table in the outer query. Then it uses a subquery, the inner query, to identify the product ID values from the orders table where the order date is later than January 1st, 2023. The outer query then filters the products table by checking if the product ID matches any values returned by the subquery. While functional, this approach can lead to multiple redundant scans of the orders table caused by the subquery, which slows down performance. Replacing a subquery with a join combines the data in a single step, reducing redundant operations and improving overall efficiency. In this rewritten query, the inner join links the products and orders tables using the product ID column. ensuring that only rows with matching product ID values from both tables are included in the results set. The where clause then filters the results to include only orders placed after January 1st, 2023. This approach avoids repeated scans typically associated with nested subqueries by directly processing the relationship between the tables and applying the filter in the same step. In summary, optimizing SQL queries requires avoiding unnecessary data retrieval, using indexes for joins, and adding filters to limit data, and simplifying nested subqueries. Each of these strategies addresses a specific inefficiency, ensuring your queries are faster, more focused, and scalable. By combining these techniques, you can transform inefficient queries into streamlined operations, delivering the desired results efficiently while reducing strain on your database. In this video, you learned how SQL queries exhibit inefficiencies that can be optimized. Addressing inefficiencies like unnecessary data retrieval, unindexed joins, redundant subqueries, and lack of filters can significantly improve query performance. Imagine you're trying to navigate through a maze. Some paths are clear while others are blocked or unnecessarily winding, slowing you down. The same happens with SQL queries sometimes. There are hidden inefficiencies that make your queries slower and harder to manage. Copilot simplifies optimizing query performance by using AI-powered insights to detect performance issues and recommend improvements, helping you write optimized queries effortlessly. In this video, we'll describe Copilot's role in optimizing SQL queries. To begin with, let's explore how Copilot query optimization features help you optimize SQL queries, starting with query analysis. Query analysis involves identifying inefficiencies in your SQL code, such as redundant clauses, unnecessary subqueries, or overly complex joins that slow down performance. Copilot scans your queries, flags these issues, and provides actionable suggestions to improve efficiency, saving you time and effort. For example, if your query retrieves all columns with select asterisk, Copilot may recommend specifying only the columns you need. This reduces the data load and makes the query faster. After identifying inefficiencies, Copilot could also recommend applying some indexing strategies to optimize database performance. Remember that indexes are data structures that speed up query performance by organizing data to make retrieval faster. Copilot analyzes your queries, identifies columns that would benefit from indexing, and suggests creating or modifying indexes to enhance retrieval speed. For example, if a column like order date is frequently used in a where clause to filter data, Copilot might recommend adding an index to that column. This can significantly reduce execution time, particularly for large datasets. Beyond indexing, Copilot can also suggest restructuring your queries for better performance through refactoring. Refactoring involves rewriting queries to make them more efficient while preserving their functionality. Copilot automates this process by analyzing your queries to suggest changes that optimize execution. For example, if your query uses a subquery in a where clause, Copilot might suggest replacing it with a join, which would improve execution time and help handle larger datasets more effectively. In this video, you learned about Copilot's role in optimizing SQL subqueries. Copilot transforms SQL optimization by automating complex tasks like analysis, indexing, and refactoring, so you can focus on building better applications faster. It's not just a tool, it's a smarter way to work.
Querying a database can be a common area where an application can slow down because of inefficient queries. You can use AI assistants like Microsoft Copilot to help you improve your queries by making them more performant, reducing redundancies, and other things. In this screencast, I'm going to demonstrate how Copilot improves SQL queries through AI-driven refactoring. I have Copilot open here. I'm going to start by just copying and pasting queries that I might have in my application or in my database. I'm going to paste in a select query, and I'm simply going to ask Copilot how I can optimize the query to improve performance. So I'll prompt it with that query, a simple prompt, and then I'll paste in the query that I want it to optimize. So Copilot will examine this query and hopefully provide us with a better approach so that the query is more performant. As queries get more complex, obviously improving the performance of those queries can greatly improve the performance of your app overall, or your database queries if you're using them just in a database. And so this is a simple select query, but we can still gain some performance improvements, and Copilot can help us with that. It's suggesting that we use a join instead of a subquery, which is a much more performant way to do a select statement. We can modify that select query by using a join. That join will help improve how the SQL query operates against the database. Instead of using the simple where clause, we are using that join, which is more performant. You'll notice the other thing that Copilot is suggesting is to make sure that we have proper indexes on the order date and product ID columns to further enhance performance. So it's making a suggestion, but it didn't give us the code that we would need to create that index. So let's prompt Copilot to provide the method, the way that we can create that index. So I'll just ask it to give me the code that I need so I can create those indexes. It tells me that I can use the create index command in SQL to create those indexes. And once those indexes are created, then I'm going to be able to use them in my queries so that I can have even more performant queries. The indexes obviously are much more valuable as you get more data, but even on a small database, starting with indexes is a good best practice so that you can get used to using them. So by using these approaches, you can use Copilot to improve queries. You can put any query or subquery into Copilot and it will give you feedback and help you improve the performance. Many times, if your queries are already very performant, there'll be little that Copilot can suggest, but it's always good to have an AI tool review the queries you're writing to see if there's anything you can do to make them more efficient and more performant.
Identifying performance bottlenecks and inefficiencies is key to creating applications that are not only faster, but also scalable and easier to maintain. With Copilot's AI-powered analysis, spotting and fixing these issues becomes an integrated part of your workflow. In this video, we'll identify code inefficiencies and performance bottlenecks using Copilot's AI-powered analysis. Let's begin by examining bottleneck patterns Copilot can detect, starting with inefficient loops, one of the most common causes of bottlenecks. Inefficient loops are loops that result in too many iterations or unnecessary nesting, which can significantly slow down your program, especially when working with large data sets. Copilot may detect these patterns and suggest better designs to reduce complexity and improve performance. For example, imagine a program that calculates the total sales for each product from a sales database. This program uses nested loops to match products with their corresponding sales data. The outer for each loop iterates over the products one by one, ensuring that each product is processed individually. Inside the loop, the inner for each loop iterates over all the sales data entries, checking each key to figure out if it matches the current product being processed by the outer loop. This approach leads to unnecessary comparisons and inefficiencies, especially as the dataset grows. The nested loop introduces significant overhead by repeatedly scanning the entire dictionary for each product. Copilot might suggest using a direct lookup to simplify the speed and logic. To accomplish this in our example, we'll want to eliminate the nested loop by replacing it with a direct lookup using the contains key method on the sales data, instead of iterating through all entries to find a match. The code now checks if the current product exists in the sales data and retrieves its value immediately. This change avoids unnecessary comparison, making the program faster, the logic simpler, and easier to maintain. Now that we've explored inefficient loops, let's examine excessive I/O patterns and how they can slow your program down. Excessive I/O operations are operations that cause programs to repeatedly access files or databases in individual steps, causing significant delays. Copilot can help you consolidate these operations, saving both time and resources. For example, imagine a program that reads log files to analyze errors. An inefficient approach might be to read each log file individually using the file.readAll text method. This method accesses the file system every time it is called, resulting in multiple I/O operations that block the program until each file is fully read. As the number of log files grows, these repeated accesses create significant delay, making the program inefficient and resource intensive. Instead, Copilot might suggest batching the reads using a loop. This approach processes all files in a single loop by iterating through the collection of file names. The program reads each file's content using the file.readAllText method, but instead of calling the method separately for each file, it consolidates the operation into one loop. This reduces redundant code and minimizes overhead by handling the files sequentially in a streamlined manner. Next, let's examine how to simplify redundant code blocks to make them cleaner. Redundant code blocks are blocks of code that repeat the same logic or actions unnecessarily, making the program harder to maintain. Copilot helps identify and consolidate these patterns into cleaner, more efficient operations. For example, imagine a program that calculates and displays discounts for different product categories. Each discount depends on the price, with higher prices qualifying for additional discounts. In this case, the repeated if condition checks the price multiple times for different discount thresholds, which clutters the code and makes it harder to follow. Copilot might suggest consolidating the logic into a single, cleaner structure. For instance, it might suggest combining repeated conditions into one simple operation, like in this example. The condition is now written in one line, making it easier to read and maintain. Finally, let's explore how to remove unnecessary dependencies that aren't needed. Unnecessary dependencies are extra libraries in your project that slow it down and increase its size. Copilot identifies unused packages or libraries and recommends removing them to keep your codebase clean and efficient. In this example, Newtonsoft.json is actively used, but system.data remains imported and unused. Copilot might recommend cleaning up the unused namespace, making your project leaner and more focused. For instance, you can use .NET Clean in your terminal to remove outdated build artifacts from your project, ensuring a clean state for rebuilding. As another option, you can rely on Visual Studio Code's dependency analysis to identify and remove unused libraries. In this video, you learned about code inefficiencies and performance bottlenecks using Copilot's AI-powered analysis. Copilot's ability to detect inefficiencies like redundant code, excessive I/O operations, and unnecessary dependencies can help you save time and write better software with confidence.
Once you've written code or downloaded some code samples from the internet, there are always ways to optimize it to improve its performance and to make it function better. Sometimes you can't see what those optimizations are, so using an AI assistant tool like Microsoft Copilot can help you find optimizations that you might not otherwise have seen. So in this screencast, I'm going to demonstrate how to apply Copilot's recommendations to optimize some application code. I've got a simple console application here, and it's got three methods: get products, read files, and apply discount. And they each do different things, and I'm going to use these three methods as examples to show how we can use Copilot to help us improve this code. In get products, we have a nested for each loop, which goes through a list and a dictionary, and it writes out to the console the items in those lists and in that dictionary. I'm going to copy this code out, and I'm going to paste it into Copilot with a prompt, and I'll ask it how I can optimize the nested loop so it performs better. So it's a very simple prompt along with the code so it knows what to analyze, and then I'll send that over to Copilot and see what it gives me. So it's suggesting that I use a single loop instead of nested loops, and it suggests that I check the dictionary for the product directly. So it reduces the complexity of the loop, and obviously when you're dealing with a lot of records, this would greatly improve the performance of that loop. You can see this is a little bit simpler than what we had before, and working over large data sets, this would perform a lot better. All right, let's go back to our program. We'll take the next one, this read files method. We're going to ask it here how we can reduce the read. So this is essentially reading from each of the text files individually, and we'll see if there's a better way to do this. So we'll go back to Copilot. Again, a simple prompt, and I'll paste in the code. Now here I'm asking it a very specific question. So we're going to the file system 3 times. I'm asking it if there's a way to reduce the number of times I have to access the file system. File system read and writes can be time consuming, particularly if you're doing a lot of them. If we can reduce the amount of times we have to go to the file system individually, that should help us improve our code. So let's see what Copilot gives us back. So it's specifically answering my prompt to reduce the number of file system accesses, which is helpful. You can read the contents of all the files in a single operation. So that's what we're looking for here. So we're just grabbing all those files once rather than having to go to the file system multiple times. Notice that my prompt was very specific and Copilot's answer was very specific. Sometimes if you're interacting with these tools and you don't get the answer that you want, it's important to make sure that your prompt is worded properly so that you can get what you want. All right, let's go back and look at our third routine, apply discount. We're setting a decimal variable of price to 150M, and we're checking if the price is greater than 1 that the discount applies, if the price is greater than 200, and then an additional discount applies. I want to simplify this statement to see if we can write it in differently. So I'm going to take this block, and I'm going to paste that into Copilot with this prompt. So how can I simplify these conditional statements? And again, I'll paste in the code. My prompt is very specific. I'm focusing on the conditional statements only, the if-thens, and asking it how I can simplify them. So it says I can use an if-else. It's a way to simplify this code. It's still using an if statement, but it's using an if and if-else. Now, I'm not quite sure that's going to be much better, so let me ask it if there's another way to do this. So it's giving me a switch option, so I can use a switch statement if I want to. So it's just giving me different ways that I can solve the same problem using different options. I tend to like switch statements better than if-thens. They're just a little bit cleaner for me. So I might choose this option over the other option. There's one final thing we want to do here. We've got some using statements in here. I'm not sure if these using statements are being used. So I'm going to take the whole code block and I'm going to put that into Copilot. I'm just going to ask it to help me optimize the code. Every time you include a using statement, it can add some memory costs. So I want to make sure I'm not doing anything here that I don't really need. So I'm pasted in the entire program and I'm asking it which of those two using statements that I can remove. It's going to analyze the code and see if it needs any of them. So it's telling me I can actually remove both of them. And because these are already included in the .NET framework, I don't need to add those, but I can remove the ones that I have in there because they're not necessary. So I'm going to go ahead and run this program to demonstrate how it works. It's going to output a few things to the terminal. This is what we see when we run the program as is. So now I'm going to take out the using statements and see if Copilot's recommendation was right, if I don't need these. So I'll run it again. All right, great. Now I'm going to go back and include some of the changes that it suggested. So I'll take the first one here, the apply discount. I'll modify that. I'll modify that one first since that was at the bottom. All right, so there's the new code. And I'm going to test each of these as I add them. I can probably test them all at once because the code is fairly simple, but I'm going to test them anyway. In case there's a bug, I can go back to Copilot and we can fix it. It worked again. I got the same exact output, which is what I suspected I should get, but this is optimized code now. I'm going to go back and try the second one, the read files method. Go back up here, copy this in. All right, so now it's going to only go to the file system one time for each file right out to the console. Let's see if we get the same results. Yep, this is the first log file, this is the second log file, and this is the third log file, which is what we have in our log files. That's the content of those files. So that worked as expected. So again, same output, same result, just a more optimized way to do it. And now we'll try the improved version of get products. Go ahead and select that, paste in Copilot's recommendation, and we'll run it again and we should see the same result. Product A 100, product B 200, product C 300, which is what we expect in a little bit more optimized way. Without the nested for each, we have a single for each loop for this using the dictionary. So these are simple ways that you can use Copilot to analyze code that you're writing or that you've received and verify that the code is performing as best as it can. And if it isn't, it will provide some options for you to improve on how you can optimize your code.
Debugging is like navigating through a dense forest. Sometimes you hit dead ends, but with the right approach, you find a clear path forward. With tools like Copilot, you can streamline the debugging process, turning challenges into opportunities to write better, more efficient code. In this video, we'll describe common debugging strategies and how Copilot assists in identifying code issues. To begin, let's explore some useful debugging strategies supported by Copilot, starting with syntax errors. A syntax error is an error that occurs when the code breaks the rules of the programming language. These errors stop the programming from running entirely until they are fixed. For example, something like a missing semicolon in C# will prevent the code from executing. Copilot can be used to find and highlight the exact location of the syntax error, helping you quickly resolve the issue and get back to coding. Once syntax errors are fixed, debugging tools like print statements and breakpoints can help uncover deeper issues in your code. Debugging tools are tools used to assist developers by allowing them to inspect how their program behaves during execution. For instance, print statements can verify whether a variable updates correctly, while breakpoints allow you to pause the program and inspect variables in detail. Combined with Copilot's real-time suggestions, these techniques can speed up the debugging process by pinpointing problems more efficiently. Debugging tools are also particularly useful for addressing logic flaws in your code. A logic flaw is a mistake in reasoning that causes the program to produce incorrect results, even though it doesn't crash. For example, an online shopping cart might apply a 10% discount instead of a 20%. Copilot can analyze the code and suggest adjustments to ensure the logic aligns with the intended behavior, resulting in the correct discount being applied. When debugging, some issues are easy to spot, but others require more careful investigation. For instance, some errors, like null reference errors, can be harder to find and require careful attention to how objects and variables are initialized. A null reference is an error that occurs when a program attempts to use an object or variable that hasn't been initialized. This means the object or variable doesn't have an assigned value or memory reference. For example, if a program tries to access a product's price before creating the product object, it will produce a null reference error. Copilot identifies these uninitialized variables and suggests appropriate initialization to prevent crashes and ensure smooth execution. While null reference errors focus on uninitialized variables, unhandled exceptions occur when unexpected situations arise during execution and the program doesn't know how to handle them. An unhandled exception is an error caused by an unforeseen event that isn't properly managed by the code. For example, if a program attempts to access a file that doesn't exist, it might crash without warning. Copilot identifies these risky scenarios and suggests adding error handling mechanisms like try-catch blocks to manage the exceptions and keep the program running reliably. In this video, you learned about common debugging strategies and how Copilot assists in identifying code issues. By using tools like Copilot, you can get help with your debugging process and write better, more efficient code.
When you're writing code or you receive code from a third party, a different source, sometimes it can be difficult to detect and resolve errors that you have in the code. You may not even know that you have a bug or a code error. Sometimes the code works fine in a normal situation, but on edge cases, there may be a bug that you don't see. So you can use AI assistants like Microsoft Copilot to help you find and resolve. The tool will help go through the code line by line and find any potential issues and suggest changes. So in this screencast, we're going to demonstrate how Copilot assists with detecting and resolving code errors in a sample application. I do have a sample console application that has 4 methods in it, and this program just simply goes through each method and attempts to run the code in the method. And I've deliberately included some errors here in each of these methods, and we're going to use Copilot to help us find what the errors are. So the first thing I'll do is illustrate that this simply will not run because it does have errors in it. So I'm going to attempt to run this, and we should get an exception even on the first method. It's starting the error demonstration. As you can see, this is the first thing that runs. It jumps into the null reference error method, and we're getting that null reference exception. Now I could try to figure this out myself, but I'm going to use Copilot to help me sort out what is going on here. So I'm going to copy this method out and open up Copilot. So we're going to prompt it by asking it what's wrong with the code. Because I saw the error in the debugger, I could prompt it with the specific error that I'm getting. Obviously, Copilot's going to be able to see here that we have a comment null reference error demonstration, which will help it. But even if it didn't, I can paste the error into Copilot and tell it that I'm receiving this error on this code and to help me find and fix that error. So it's looking at the code. It's not looking only at the comments. It's looking at the code and telling me that I'm trying to access the length property of the message string, but that's set to null. And that triggers this null reference exception. So it's providing some updated code so that I can fix that error by checking for null first before we attempt to access the message object. If the message object is null, then we're going to write out that it is null. So I'm going to go ahead and fix this by pasting in the new code. So that's our updated code. Now we should get through the null reference error method by running this. We're getting more errors because on the second one we have an unhandled exception again, but notice that the first one ran, the message is null. So now that code that Copilot suggested, if the method does not equal null, that if-else statement is now trapping for that null error. So we fixed the first one, and now we've got an error in the second one. So I'm going to actually use the error message on this one. I'm going to copy this code out, and I'm going to paste that into Copilot first, and I'll go back to my code. I'll let it know what I'm getting. So I'm going to take that error and I'm going to tell Copilot that I'm getting a specific error on this code. So I'm giving it the specific error, unhandled exception, system IO, file not found on the code below. Can you tell me how to fix it? The problem with this code is that it's trying to read from a file that doesn't exist on the file system. It's telling me this is good best practice. Always add a check to see if the file exists before attempting to read it. It's using that if statement again, but it's going to use the file.exists method, passing in the file path. If the file does not exist, then we get the console write to the line that it does not exist. If it does exist, it'll write the contents of the file out to the console. I'm going to copy this method out and paste that into this second method. So I'm going to simply overwrite this method with the code that Copilot gave me, but I don't want this because we already have that at the top. Okay, so now it's a little easier to read. So now we're going to try to run this again. We should get, again, our first one runs fine. The messages should show the message is null. The next one should show the file at the specific file path does not exist. So let's go ahead and run that again. The message is null. We're getting the file non-existent file.txt does not exist. The logic flaw demonstration runs, but there's an issue with it. So we're going to see if Copilot can help us find the logic flaw. Now notice that this seems to run just fine. If we weren't looking carefully at this, we would think that we didn't have any issues with it. But let's see if Copilot can find where the logic flaw is in this next method. To address this, I'm going to copy and paste the demonstrate logic flaw and the apply discount to ask Copilot about this. Now notice in here we've got a comment. This method should apply a 20% discount for prices over 100, but it's only applying 10%. So I'm going to have to tell Copilot what my goal is and then get the correct result back. Now in this case, it's probably fairly easy to find where the issue is, obviously because it's commented, but we can see that this is only applying 10%. But in more complex code, it could be difficult to figure out where the problem is. We can use Copilot just like we're using it in the simple example to apply to much more complex examples. So we see that it did fix this here by applying the 20. Now I could look at this and say, okay, I've seen what Copilot has done here. So instead of copying and pasting it, I'm just going to go in here and change this to 20. Copilot helped me locate what the issue was, and I could see in the code where it changed. And so now I could just go into my code and go ahead and apply that. So let's go ahead and run that again. And now we've got a discounted price of 100 instead of 135, which is the 20% that we were looking for. So that solved that issue. Now we've got one more, this unhandled exception. We'll do the same process. I'll take the method. I will let Copilot know what my issue is. I'm getting a divided by 0 issue. I'll paste in the code, and Copilot should help me find and fix the bug. You're going to check to ensure that the divisor is not 0 before the division. So it's giving me some common best practices of always checking the variables before trying to work with them or apply logic to them. So it's giving us another if statement. If the divisor does not equal 0, and it's above 0, then we can apply the division operation. Otherwise, we should return a message. So that's a common best practice. So again, we'll go ahead and paste that in. So now we've got the new logic that Copilot provided. And now when I run this application, each method should run without errors.
We've got at the start here, starting error demonstration. First one, the message is null. The second one, the file, non-existent file, that text does not exist. We fixed our logic bug with the 20%. And for the unhandled error exception, error division by 0 is not allowed, which is what we'd expect because we are passing in 0. And then the error demonstration is completed. Now to fully test this, obviously we can change our divisor to something like 2 and run it again. We can go through each of our methods and make sure that the other paths work as Copilot provided it so that we know that there's no other errors. If we do encounter other issues with the code that Copilot provided, we can go back to Copilot and work with it to help us fix those problems. So these are simple ways that you can use a tool like Microsoft Copilot to help solve code issues. And it's always a good practice to review your code, obviously, run it through an AI tool like Copilot to see if there are any errors or issues. And then always check the code that Copilot returns because there still might be logic bugs. Sometimes Copilot may not have the full context for what you're trying to accomplish and may miss some things. So it's always good to review and then test the code that even you're getting back from the tool.
Efficiency starts with clarity, and performance optimization is no exception. Defining the focus, setting measurable targets, and using the right tools are keys to making impactful improvements. A structured plan helps transform complex challenges into actionable steps, ensuring progress is both systematic and effective. In this video, we'll plan a structured performance optimization project integrating AI tools and best practices. To begin, let's explore the steps to planning an optimization project, starting with defining the project scope. The project scope outlines the boundaries of the work to be done within a project and specifies the key areas of focus for optimization. For example, if users experience delays, it could signal the need for query optimization, code refactoring, or resolving database bottlenecks. Focusing your efforts on specific areas ensures you can prioritize effectively and avoid spending resources on tasks with minimal impact. After you've defined the project scope, each area you've identified, such as slow queries or high resource consumption, needs a performance metric. Performance metrics are quantifiable targets used to evaluate success and measure improvements. They provide quantifiable data to assess progress, identify issues, and guide improvements. For example, if your goal is to reduce query execution times from 500 milliseconds to 100 milliseconds to keep CPU usage below 70%, metrics not only measure progress, but also guide your decisions throughout the project by showing what's working and what isn't. Now that you have defined the scope and gotten your performance metrics, AI tools like Copilot can streamline your optimization process. AI tools in the context of backend development are software platforms that leverage artificial intelligence to diagnose and optimize performance challenges in applications. For example, Copilot can help identify slow database queries and suggest adding indexes or optimizing joins, saving time and ensuring best practices are followed. Now that you've set goals and selected your tools, the final step is to create a work plan and organize your tasks into manageable phases. A work plan is a structured schedule that breaks tasks into phases, such as analysis, optimization, and testing to ensure systematic progress. In the analysis phase, you will use performance tools to pinpoint issues, such as slow queries or high memory usage. Address these issues during the optimization phase by refactoring code, adding indexes, or leveraging AI tools like Copilot for effective solutions. Finally, testing phases measure results against benchmarks, ensuring your changes achieved the desired performance goals. In this video, you learned how to plan a structured performance optimization project, integrating AI tools and best practices. By combining clear goals, AI tools, and a structured approach, you can turn performance challenges into a measurable improvement that creates a better user experience. Every slowdown in your application, whether in code or database queries, can impact time, resources, and user satisfaction. By using Copilot, you can uncover bottlenecks and transform sluggish processes into seamless experiences, optimizing both performance and user experience. In this video, we'll demonstrate how to use Copilot to identify key bottlenecks across both code and database queries. Let's begin by exploring the steps for bottleneck detection, starting with scanning a codebase with Copilot. You can describe the issues directly to Copilot by inputting a prompt like "Identify performance issues in this file." You might also provide a specific section of code from your project where you suspect inefficiencies. Copilot will then analyze the code, highlighting areas for improvement, such as redundant loops or other inefficiencies, and offering suggestions for optimizing them. An example flagged by Copilot might involve a loop that processes an array. The code calculates the sum of all integers in the data array by iterating through each element using a for loop and adding it to the sum variable. While functional, this approach is unnecessarily long and susceptible to manual errors. Copilot might suggest a more concise and efficient approach using the sum method, which directly calculates the total sum of all integers in the data array. This approach eliminates the need for manual iteration, improving both the readability and accuracy of the code. Now that we've reviewed code bottlenecks, let's examine how to analyze SQL database queries. Copilot can identify inefficiencies, such as retrieving unnecessary data or missing indices, and provide actionable suggestions to optimize performance. Imagine a scenario where you need to retrieve customer orders, for example. This query selects the customer ID and order date columns from the orders table in the sales DB database where the customer ID equals 123. While this query retrieves the correct data, it may perform slowly due to the lack of optimization. Copilot might recommend optimizing the query by adding an index. For example, creating an index on the customer ID column in the orders table of the sales DB database can significantly reduce query execution time. This optimization improves lookup speed, making the query more efficient. After identifying bottlenecks, it's essential to document your findings, implementing Copilot's recommendations, and prioritize fixes. This ensures your team understands what to fix, when to fix it, and why. Finally, let's explore how all these steps work together in a real-world scenario. In a customer management app, Copilot detects bottlenecks by analyzing both the code and the database. For the code, it identifies inefficiencies like redundant loops or operations that could be refactored for better performance. In the database, it pinpoints slow queries caused by missing indices or unnecessary data retrieval and offers targeted optimization suggestions. Copilot provides actionable recommendations, like replacing loops with too many details with streamlined methods or creating indices to improve query execution times. You can systematically enhance the application's efficiency by documenting these findings and prioritizing fixes based on their impact. In this video, you learned how to use Copilot to identify key bottlenecks across both code and database queries. By leveraging Copilot's insights, you gain powerful tools to uncover bottlenecks and implement meaningful improvements, turning potential performance challenges into opportunities for growth. Congratulations on completing the Performance Optimization and Scalability course. Mastering these concepts is essential for building efficient, reliable applications that adapt to growing demands. Optimizing performance enhances user experiences and ensures today's systems remain robust and scalable in today's dynamic technology landscape. We began by exploring caching strategies, focusing on how in-memory and distributed caching can enhance application performance. You also examined cache expiration methods and best practices to ensure systems remain efficient and scalable. Next, we learned about database query optimization by investigating indexing strategies, analyzing query performance, and refining complex queries. We also identified best practices to ensure databases operate efficiently and deliver consistently high performance. After that, we focused on the foundations of scalable application design, analyzing key architectural approaches, implementing load balancing strategies, and leveraging asynchronous processing. These concepts laid the groundwork for creating flexible and efficient systems ready to handle evolving requirements. Finally, you utilized Microsoft Copilot to enhance application code and database performance. By applying its advanced features, we identified performance bottlenecks, improved code efficiency, and implemented robust strategies for optimizing overall system performance. You're now equipped with the skills to optimize performance, design scalable applications, and enhance workflows with Microsoft Copilot. Use this knowledge to build robust, efficient systems that adapt to evolving demands and drive innovation in your project. Congratulations on completing the Performance Optimization and Scalability course.